We start in 30 minutes.
I finally hear music.
Hi.
Hi. Do I hear
You
music?
do.
Ah, it worked.
It worked. I don't know how, but it worked. You know, they say that if you keep doing the same thing, hoping for a different outcome, you're crazy. Well, I kept doing the same thing,
It's often
but in the end, it
successful.
worked.
Yeah. Nicely psychedelic.
Yeah. Well, you have the right T-shirt for that. I like
Mm.
tie dyes.
I better wear something different tomorrow.
Well, I'll show you my T-shirt as well. Now we are doing a T-shirt contest.
Is my sound good?
Yeah, you sound perfect.
Nice.
The Nautilus.
Great. So I'm planning to do the beta slides where I'm going to use my slides as my virtual background.
Nice.
I tested it over the weekend. I modified my slides so I have myself in a little box. I'm pretty excited about it.
I am excited too, actually.
It seems like such a more natural way of watching, having the person and the slides.
Yeah, I'm actually curious to see how it goes because I can agree with you that could be interesting. Yeah, I don't know.
Yeah.
People are getting very creative. I mean, Kai this morning tried to be creative.
What did he try?
Oh, he was really standing. You could see all the way from the feet to his head.
Oh, I see. He went back there. Yeah. I could do that too.
He had somebody with a professional camera, it looked like.
Yeah.
It was zooming.
Yeah, I still think the head, actually, I'm going to see if I can find a good angle. I like being
me
close.
Too. Like this, something like that. Yeah.
Yeah. And I don't know.
This weekend I was watching a physics professor or something, or computer science or something, and he was in a real professional studio. I think he was from UC Davis or so.
Mm-hmm.
And he had a nice black background. He had a spotlight on him, and he was writing apparently in reverse. I don't know how he did that, through a mirror or something. He was writing on a see-through glass screen in different colors pens, and it looked so good.
I'm not doing anything right now that requires chalkboard, but it is awesome to see the innovations. I am also, I had this thought when they were closing down the ground-based telescopes, where I was like, you know what, like just close down all the telescopes for a year and make us learn how to analyze our archives better, force our hand.
Mm-hmm.
And I feel like the pandemic has done the same thing for remote work, where it's like, all right, we've been gently pushing in this direction for a while, and there's been a lot of resistance. But now it's like, sorry, no choice. And now you're forced to innovate. And the people who are like, I never want to do anything remote are now like, oh, it's actually not that bad. And I'm really thankful for the opportunity for us to learn new things.
Yeah, but I really want to go to Cape Town next year.
Oh, right. Is that where ADASS is supposed to be?
Yeah.
Okay. Why did the angle change all of a sudden? Oh, I know why. Just because
so who are our
Kathleen is the chair.
I see.
She's just reminding us that we are being broadcasted on YouTube.
Uh-oh.
But yeah,
all of our chit chat.
Yeah, but,
I haven't. I haven't said anything that I don't mind.
Exactly. And you know what? Everybody will be jealous of our T-shirts. That's it. What can I say?
Competition.
But that's a good
Exactly.
reminder. Thank you.
Mhm.
Runtime disconnected.
So will I be able to see the chat or the Q&A? Yes, so I'll be able to see the Q&A if I wanted.
Yeah.
And so Kathleen, you're going to be chair?
Yes, I'll be chair, so I'll be monitoring those questions, and I'm
Okay.
the one who will be reading them back to you.
So
I want to stay on top of that.
I'm going to see how it goes, but I plan to now pause in a couple places to answer some questions.
Okay, thanks for the heads up.
Yep.
Yeah.
And I'm going to aim for talking for 20 minutes and saving 10 minutes for discussion. Is that the plan?
Sounds perfect.
Okay. Well, we'll see how question goes. I have a feeling that there's going to want to be a lot of discussion. And will it be possible if you see Brigitte raising her hand to allow her to speak? That would be amazing, because she's just she's going to be able to, I suspect she's going to have something to say for a lot of the questions.
Mike, you're the room manager. Will you be able to do that?
Sure. She's actually
Okay.
going to be the speaker next after you, or two speakers later, so she should be in the session.
Yeah.
Great.
I don't see her quite yet, but we are still 10 minutes from the start, so
I'll keep an eye out for her.
join.
Great. Should I try to share my screen yet, or not until I'm introduced? Probably not until I'm introduced, right?
Yeah, let's wait another 10 minutes so that we leave also time for people to show up. We have seen the number climb up. So Brian, I'll switch your video off. Where is that? Stop video. Okay. Peter, I will also switch your video off. Well, yeah, there you go. I will also switch my video off. And I'll mute myself and get out of your way.
Well, this is boring now.
Fine.
Could provide entertainment. Are you one of the few people who is allowed in the office?
So I'm at the Flatiron Institute, which is the Simons Foundation, where the Center for Computational Astrophysics is. And they have got a really great setup for allowing people in. I'm on a floor that actually doesn't have that many people in it, so I get to sit at the same desk every day. The actual astrophysics floors are actually quite crowded, and so the admins do a seating arrangement every week to keep, so people that are in people that live together share an office, but everybody else is in one office per. And then distributed, spaced out in the common areas. So it's really amazing here. They've done a really great job. I think they updated the HVAC system back in like April. So the common areas are as air circulated almost as outside, without being freezing, which was one of the things I was worried about. So yeah, it's been amazing to have the Flatiron Institute during the pandemic. Did that answer your question, Peter?
Yes.
Uh-oh. I'm still here, right? I just got a notification from Zoom saying I'd been signed out. That's weird.
We still see
Are you
you.
on a Linux machine?
No.
No. Maybe try restarting your Zoom client. We were warned
Well,
that's,
I mean, if I'm still here,
yeah.
it may, yeah, and my name stayed the same and everything. It just signed me out, it said. So it didn't like bump me out of the meeting.
Okay. Some people have reported that when they were promoted from attendee to panelist, they were kicked out of their desktop client, but just restart and you should be fine.
Okay. I'm not going to touch anything. I do have Discord open. So the back channel for this talk, so if people were to be talking about the talk during the talk, it'd be in the talks channel.
Yeah.
Okay.
Yep.
Great. Can I see this one yet? Okay, good.
What is the significance of the in the pre-talks in the schedule? There is now 01053 is green. What is the significance of that one that is green?
It's a very important significance is the fact that I managed to fix this JavaScript stuff that was not syncing up with UTC. And so green is what's happening now or in like 5 minutes. In my case, I don't see Kelly's talk as green. The fact that you see it as green might mean that I haven't fixed it.
No, I see the talk after Keller is green, after the break.
Oh.
In fact, the first talk after the break. And the same thing was this
Peter.
morning. It was like one talk ahead.
Don't tell me these things. I
think you got a time zone error in your UT thing.
I think so. Damn. Well, I'll look at it again.
I think that's highlighted with according to the time of your browser or your laptop. So what I have found in the schedule, I found that the contribution of the talk that is highlighted in green are the one that is running now. Well, it's not running, but it's more nearly running now because it's 1 UTC time. So the browser interprets that the time is local time instead of UTC.
So I was just chatting with Brigitte and she's double booked. So, oh well, good try. Let's see if there's anybody else. Oh, Adrian is here. So Adrian will be a good person to allow to speak at some point if we get a bunch of questions about like development and the contribution workflow.
Just have him raise his hand and I'll allow him to speak.
Okay, I think he's raising his hand now, just so he can be there, so we don't have to have awkward waiting for it to happen during the talk.
Okay, I'll leave his hand up so I can find him easily.
Okay.
Once the questions begin, I'll let him turn on his mic.
Okay.
All right. It is the hour on the dot. Cannot say which hour it is, but it is the hour. I'm Kathleen Labrie. I'll be chairing this session. And without further ado, let's just get started. Our first speaker is an invited speaker, Kelly Cruz, who's going to talk to us about AstroPy. So I'll take it away. You should be able to share your screen and your fancy screen.
I'm so excited. So I'm going to try the new slides as a virtual background. Hi, everybody. Good morning, good afternoon, good evening. I'm super excited to be talking about the AstroPy project with y'all today. Okay. Oh, here I am. Amazing. Super excited. So hi, everybody. I prepared some updates for the ADASS community. Typo on the first slide, that's fine. And I'm representing the project from the coordination committee. So I'm on the coordinating committee of the AstroPy project. It's a 4-person committee at the moment. And I'll talk a little bit about governance changes later on the talk. And I'm also an associate professor at CUNY Hunter College. I'm based in New York. Before I get started, I also want to, give special thanks. So like most things in the AstroPy project, it's a community collaborative effort. And a lot of the slides I'm going to be showing and graphics are from Adrian Price-Whelan and Brett Morris. And I want to thank Paleon Lim for giving me some helpful feedback on an early version of the slides. Feel free to tweet. There's nothing, I've got nothing private in the slides. Let's see. All right, so the AstroPy project has a couple components. I think most people are used to thinking about the code ecosystem, but not only is there the core package, which is, import AstroPy, but there's also the coordinated package and the affiliated packages. And so I'm going to spend the first, third of the talk talking a little bit about the code ecosystem. I'm also going to talk about, another big component of the AstroPy project, which a lot of people in the ADASS community may not be familiar with, are education resources in the Learn AstroPy project. And so we've been working both on developing content, so the content of tutorials and also workshop content and things like that. But we've also been developing infrastructure for supporting educational materials. And so that's something which might be of use to y'all if your projects are also developing educational content. That's something that we can work together on. Most importantly, really what I want to talk about today is our community of maintainers, developers, and contributors. And I'm going to throw a lot of information at you, but what if I could spend the whole 20 minutes making this a recruitment talk and like trying to figure out how to get more of y'all involved as contributors in the AstroPi project, I would. So that's going to be the big takeaway. And we of course have a big community of users that have various forums and stuff. I'm not going to talk about that today. Unless people, want to ask questions or whatnot. I will be pausing at a couple places before I switch topics for questions. So if you have questions as they come up, please feel free to put them in the Q&A, and then Kathleen will moderate them when there's a good time. So in addition to the AstroPi core, there's also coordinated packages. And so this is a system which we came up with. I think it's maybe been in the past 2 years. But so in addition to AstroPi, there's AstroQuery, which I know many of y'all are familiar with. There's also sort of fundamental packages like regions, AstroPi heal picks, and reproject, and things that are used especially by a broad segment of the ground-based community, which are FOAT utils, CCD proc, and spec utils. So these packages are we see them as fundamental to the ecosystem of the AstroPi project, and we intend to manage and support these packages with the same amount of detail and attention as we do AstroPi core. So those are the coordinated packages. We also have a network of affiliated packages. So affiliated packages form an extra layer of the ecosystem that they're specialized, domain specific, but still interoperable packages with the rest of the ecosystem. So something like if I wanted to make a special analysis software for brown dwarf spectra, for example, and if I wanted to be sure that it uses spec utils and AstroPi modeling and all of the API and interface standards in AstroPi, I could develop that and apply for it to have an affiliated package status. We actually have a review process, and in the past year, we've actually formalized that review process a little bit. And so new packages that apply for affiliated package status are based on functionality. So, does it work? Does it do something useful to the astronomical community? Integration with the AstroPi ecosystem. So that's also, minimizing duplication. So does it use things that are already built into AstroPi core rather than reinventing the wheel? Documentation and testing. Honestly, the bars for documentation and testing are a little bit lower for affiliated packages. And so we use a lot of these review criteria to encourage best practices in development and not necessarily to stop projects from having affiliated package status. Also development status. And so development status is how well is it being maintained? And so that's an important one when packages get re-reviewed if they're currently under development. And Python 3 compatibility, which is something that is not as common these days. Throughout the talk, I have a whole bunch of URLs. I assume that at some point I'll be able to put these slides where everybody can see them. I'll definitely put them on SlideShare so that you'll have access to all the URLs. Okay. So a little bit more, so the popular package, so this is weekly PyPy downloads as a function of time. And then I've made the labels in approximate order in their download order. So you can see AstroQuery and FOAT utils are the most frequently downloaded. AstroPlan is up there. Spec utils, I expect spec utils to get more and more downloads. Glue, SynFOAT, CCD Proc, Ginga, AstroGala, AstroML, and Stingray are among our most popular packages, just to give you a sense of their popularity. So here's a summary of everything that's been new in AstroPi since January 2020. So there's actually been 2 releases since January 2020, version 4.0 and 4.1. I essentially randomly just chose things from the what's new. The point of this slide is to show you that the AstroPi project is, really improving. There's active development going on, bug fixes are happening. The project continues to be healthy and being actively developed with new features being implemented. The AstroPy core library, also just to show you some stats, and that we have the stats in particular, is very popular. So we have about 100 citations per month and growing, over 3,000 citations total, 16,000 dependent repositories and 879 dependent packages. So that's a lot. I also think it's helpful to note how useful it is that we did write a paper in the traditional, in the traditional way. So actually, I'm not sure if it ended up in Astronomical Journal or Astrophysical Journal, but whatever, it's a easily citable paper that makes it easy for us to demonstrate its impact and usage in the field. For a lot of y'all, so things that are important. So the 4.0 series is the long-term release. So the plan is to support AstroPy version 4.0 until 2021. AstroPy 4.0 is the first long-term support release that only supports Python 3, so no Python 2 support. Something which we've been discussing very recently, which is to adopt adopt a schedule for upgrading the requirements for Python and NumPy. And so as of April 2021, we're going to bump to Python 3.7 and to NumPy 1.17. If you take a look at that AstroPy APE, so that's an AstroPy proposal for enhancement discussion, there's actually a table of dates that has our expected requirements. And so that's going to be changing. I think it's like maybe every 9 months or something like that. And I think, yeah. So at this point, I'd like to pause and see if there are any questions about the AstroPy core functionality, affiliated packages, coordinated packages. Great. Azali asked a question. Any other? Well, I'll just take Azali's question. So Azali asked, what's the status of SpecReduce and how do you see it moving forward? Is there a roadmap? Is there funding? Azali, that's a great question. To foreshadow some slides, there is funding, but we don't, there also is a roadmap, I think, in the APE, but the status of it moving forward is that it needs a lot more, I think we basically need to reevaluate where we are with SpecReduce. So since we did get funding so the AstroPy project received a MORE grant in October of 2021. So that's jumping ahead to slides I have later. And so a lot of our focus in the past year has been just adjusting to the fact that we have funding and figuring out how to spend it and how to decide how to spend it, which is extremely non-trivial. And the funding in that there is money in that MORE grant for attention to the spectroscopic reduction capabilities, but that I think is going to be a focus in 2021.
On Discord, some people are asking, first, why change to 3.7 and why not 3.8?
Oh, that's not a question I can answer. Is that? I know that they were following the NumPy enhancement proposal, NEP 29. And so I'm not sure if that's just a community decision. Is that something, Adrian, that you can address? Or if anyone else has an answer?
Yeah, a more complete question was, what is the rationale for requiring Python 3.7? And is there essential functionality that AstroPy depends on?
I mean, I don't have a concise answer, I guess, but you always have to find the threshold of when to improve our code base, because we can then rely on stuff that has been implemented in Python versus supporting older and older versions. And so we just decided to adopt the NumPy schedule. And yeah, I think that switching to 3.7 will allow us to remove a lot of legacy code, things that we had to implement that didn't exist in the language. That I can point you to specifics if you want to know, but that's the short answer.
And now, Kelly, do you want to continue with your talk? Are you okay with another question?
I like the questions.
Okay. So when and how did you decide that the project was mature enough to go for a classical journal publication?
Oh, that's a great question. So most recently, we actually worked on the second paper. So AstroPy wrote the first paper, which I don't think I was a part of, relatively early in the process. But at this point, if we had staffing, I think to write a paper every year, we would. Adrian was actually on one of the leads, I think, on both of those papers. And so, Adrian, do you have any other thoughts on that?
I guess, yeah, we did it. Kelly's right. We wrote the first one in 2013, which was when AstroPy was pretty young, and the most recent one was in 2018. We did it primarily as a way to just hack the credit system, and I've always been hoping that there would be other ways to do that would crop up. But since this does seem like the most the most efficient way, I guess, of getting people credit that they can take to their employer or whatever, I think Kelly's right. We should be writing them more frequently. But
yeah, I mean, and I would encourage folks to you know, like they say, write early and often, publish early and often. Especially now, I'm not familiar with MNRAS, or I'm familiar with the AAS journals the most, which is that they have a specific, you know, software editor now. You know, they're really encouraging. They want people to submit software papers, and there's also simultaneous publishing with the Journal of Open Source Software and astronomical journals at the same time. So AAS Journals is going to a lot of effort to welcome and support software papers. So I definitely highly recommend trying it. All right, good. Now I think I'm ready. Now I think I'm ready to move on. Great questions.
Yes, excellent.
All right, so because of time, I actually don't want to spend too much time talking about the Learn AstroPy project, especially because the site is in the process of getting an overhaul. So we're expecting a full site overhaul in 2021. And as part of that overhaul, we're actually gonna introduce cross-platform searching. So if there's a tutorial that exists on another site, someone could search for it. Like, let's say Gaia had a whole suite of tutorials. We could include the Gaia tutorial site to be discoverable on the Learn AstroPy website. And so there's going to be potential for both for tutorials to be cross-listed, or if y'all have a bunch of tutorials but you don't have a home for them, we also will welcome contributed tutorials. So the vision for the Learn AstroPy site is that it not just be a place for users to learn AstroPy, but to learn astronomical computing in Python, or eventually, we just see this as a home for a whole bunch of tutorials. Also, please check out the NB collection package. So this is actively under development, but it's gone through a couple different package names, and I think it has the potential to be super useful for the community for both testing and rendering Jupyter notebooks as HTML. And so that's all I'm going to say about the tutorials, because I want to get to my recruitment pitch, which is trying to get the sort of creative juices flowing. And a lot of what I'm going to say actually dovetails with a lot of the discussion. So I was looking at the birds of the feather discussion, the interoperability of users, managers, and developers. And so right now, it seems like in many organizations, it's not straightforward to see how the everyday developer would be able to contribute to AstroPy. And so I want to give some examples from other organizations about how this can happen, to try to shift the culture a little bit and to inspire managers, developers, future managers, to how we can modify the landscape to support more open source development. And so Chandra developer implemented a flexible way to add persistence attributes to an AstroPy table in their own application, and then later ported that feature to AstroPy. The Rubin Observatory has updated code code for constructing color images, but also they contributed documentation updates, which is super useful. Added support for new units, which I expect was something that they needed for their own applications, and they did bug fixes. Similarly, developers of the Cherenkov telescope array had a great contribution to speed up coordinate transformations for large arrays of observation times. So that's something which I know a lot of people have pointed out, is that a lot of the AstroPi core was built for thinking about small scale implementations, and that development is needed to make it more efficient for big data type operations. But they also, just contributed bug fixes and enhancements. So just making things better for everyone. And of course, JWST developers at Space Telescope develop and maintain the WCS modeling subpackages and the PhotoUtils in regions coordinated package. And so one thing that so these are, organizations which are contributing to the project, but they're existing in an ecosystem where they see the AstroPi ecosystem as a part of their scientific stack and not as something separate. And so it might be difficult to sort of backport existing software to make contributing to AstroPi on task, in scope. But I think moving forward, thinking about new projects moving forward and how you can make an AstroPi, AstroPi or a coordinated project or even an affiliated project, a dependency and work in that ecosystem, then will make it easier for to justify and to make it in budget development within the community tools. A little bit about the contribution workflow. So if you don't just already have an idea because you've encountered a bug or because you have some frustration with an AstroPi feature that you use, there's plenty of room for inspiration and finding things to do in the issue tracker. So there's over 1,000 open issues with a pretty extensive tagging system, label system. So I feel like there's an issue for everybody in there if you're looking for something. And this is also an awesome thing for students or interns to also do. So if you're thinking about mentoring students or folks newer to coding or newer to astronomy, that could also be a really great place to start. I cannot overemphasize the wonderful community that we have on Slack. And so if you're not quite sure if an issue is stale or if something is harder or easier than you think it might be, pretty much all of our package maintainers are on Slack. And so you're absolutely welcome to discuss via the GitHub issues, but I also highly recommend Slack, where there are channels, specific channels for every subpackage. We also have extensive documentation for the code guidelines and for the development workflow. We also ask that pull requests have an update to the documentation, that they have tests, and that there's a change log entry, and that's discussed more in all of these guides. And again, there are for a good forum for discussing how to implement all of these things is in the Slack channel. Usually there will be pull requests. Usually there will be, I don't want to say extensive, but discussions, because a lot of people care about AstroPi, and so we definitely need the contributors to not just submit pull requests, but to engage in those discussions and submit revisions. And so contributing maybe require a little bit more patience and a little bit more back and forth than some of the development workflows that you're used to in your own organizations. So be emotionally prepared for that. So again, we for the ADASS community especially, we really would love for y'all to join us. And so the AstroPi Slack is a developer focused. There's channels for each subpackage, so you can pick and choose. It's not super noisy if you can hone in on which subpackages you're the most interested in. Anybody can join using this URL. If you're not on Slack or for whatever reason you prefer a different channel, so we do have the AstroPi Dev Google group, which is where we announce major changes or have major discussions. Sometimes we'll point to a GitHub issue and say, hey, we're thinking about adopting NEP 29 and figuring, deciding our adoption schedule or modifying the release schedule or something like that. Those types of major changes and or discussions are brought up on AstroPi Dev. So I highly recommend joining that Google group just to stay in the loop. Yeah, I think I'll just keep going before I ask for more questions. So as I said earlier, in response to Azali's questions, the AstroPi project now has funding. And so we got about $900,000 from the Moore Foundation over 3 years. It started back in October 2019. And as I'm sure most of y'all are aware, this is a really major change for the project. For our year one, or phase one, as we call it, we focused on funding for the existing core maintainers. So I call it keeping the lights on, everybody who's already doing a bunch of things to get support. As contractors, summer salary, teaching release. We did not use any funds to support full-time. There are no full-time positions. So all of it is for people who are working on AstroPi part-time and to support that part-time effort. We've also made a lot of progress, and so we had a whole dedicated working group on formalizing our governance structure and charter, so that we can make decisions in a more documented way. And so that's also currently still under discussion, and we're calling it APE 0. So because it's our charter, so AstroPi Proposal for Enhancement 0, going back in time. And so that's currently pull request 61 in the AstroPi APES repo. Another change which we've implemented this year is working towards radical transparency. So the notes from the Interim Finance Committee now are a public Google Doc. The notes from the coordination every 2 weeks or every month coordinating meeting are now also available for view and comment. And the things which those committees are working on are also posted in the AstroPi project repo as issues. So folks can see, what we're working on, what types of decisions we're making, and what's going on. And I'm very, very happy with that. It's definitely, at least so far, led to a lot of discussion, and we're happy to have more people taking a look and giving us not giving us, but contributing to the discussions and the decisions which are being made. Planned activities. So what we did in phase one was just phase people who were already doing things like and there was some stuff for that wasn't already being done, like new stuff, but for the most part, it was a lot of keeping the lights on. For phase two, we want to focus more on funding community-led efforts. So for example, if someone said, I really want to push on spec reduce, that would be something which we'd be interested in funding in phase two. We also want to apply for a NASA grant. So one of the goals of the Moore funding is to get our governance structure in a state where it is more appropriate and we can be more competitive for things like NASA grants. And so there is a new call, which I also want to call everyone's attention to. And so it's in NASA Rose's 2020 E7, it's called, and it's support for open tools, frameworks, and libraries. And it is specifically for maintenance of existing packages. It is not for new development. And so it's a new chapter in our world of funding available for software. And I'm really
3 minutes now. Sorry.
Thank you. Yeah, so since I do want to have time for more questions, so the goal is to use the grant funding, the NASA funding as well, to support the community development model and not to uncover the entire cost of the project. So we're not planning on hiring full-time people. Our plan is to distribute the money, across the community to facilitate more community engagement in the project. So we still want you. So my summary slide, the Astro project is healthy. The code base is well maintained and growing. We're getting funding, and we're thinking hard and being careful about how to spend that funding to help with sustainability and enabling growth. We have the Learn AstroPi site, which is a potential future home or discovery portal for your project's educational resources. And we would love more contributors from the ADASS community. Thanks. And so I'll take the last 3 minutes for questions.
Anybody has a question? Nothing yet. Well, if not, I'll take the opportunity to ask one. A few years ago, I looked into contributing, and I found that it was very daunting having to read all the documentation needed in order to contribute, and that really put me off. Even though it's my job to write software. So has this been addressed? Because I know it was a known problem and there was some interest in fixing that.
Yeah, so the way it's being addressed in at least 2 ways at the moment. So one of the things that we did in phase 1 is that we hired a, what did we call, software operations support specialist. And so Madison Bray is now part-time to help with the contribution pipeline. And so we have a person who's tasked with seeing the pull requests, saying like, oh, maybe this isn't passing tests, or maybe you didn't add documentation, and offering help with that, or doing it like if it's something like there's something obscure, or you just need to add a change log entry, you know, helping get those PRs across the finish line. So we have a person dedicated to making that easier. And to, I think something that's also on Madison's list is updating and the documentation. I think the documentation is important. You know, we don't want to, like, we want to make it easier for folks to contribute without necessarily lowering our standards, which is a challenge. And so we want to provide more support for the contributors so that it's basically less work and easier. Another thing which I skipped over, right? And so one of our planned activities is to institute a contributor to maintainer mentoring program. And so that's also a place where we're hoping, if folks have maybe made, you know, 1 or 2 contributions, to provide them with more support to become a maintainer. And so it's also the more maintainers that we have, so the more people who are taking a leadership role in supporting a package or a sub package, I think the more support we'll have for folks to make contributions. So it's definitely something that we're aware of and we're still working on. It's a great question, Kathleen. Adrian, did you want to talk any more about the role of the SOS position in supporting contributors?
I think you summarized it well. But I think, yeah, the idea is to take a look at all of these questions, not just helping with pull requests and that, but also look at the pipeline of going from user to contributor to maintainer.
Okay, well, thank you very much, Kelly. And here, the applause.
Thanks. Thanks everybody, and happy to keep chatting in Discord.
And for now, if it's Kelly, can you stop sharing your slides, please?
Yes.
And here we go. Thank you very much, Kelly. So now we're taking a 15-minute break, and we're coming back with contributed talks. 3 contributed talks, a focus demo, followed by a buff. Busy morning for me. Thank you, everybody. See you in 15 minutes. We will be resuming the session in about 5 minutes. All right, everybody, let's resume. Our next speaker is Enrique Fleischhack of the Catholic University of America. He will be talking to us about multi-wavelength astronomy with the 3ML framework. I will give you the spotlight.
That's the wrong slide.
Oh,
give me a second.
And she will be. I apologize.
No worries.
Okay, great.
Okay, it's not giving me. Sorry about this. It's not giving me the right slide.
It happens. It happens.
Let me try again. Okay, now hopefully.
Looks promising.
Okay, great. Sorry about that.
Take it away.
Thank you very much. So I'm going to talk about the multi-mission maximum likelihood analysis framework, 3ML, which is an analysis framework that is being used, has been used for a few years to do multi-wavelength astronomy. So why do we need such a framework? So here's just a recent example from a paper that was published about 2 years ago from follow-up observations where people were looking for a counterpart for an ice cube neutrino flare. And you can see here there's more than a dozen of experiments that contributed data. So astronomy more and more is getting to a point where we're not just looking with 1 or 2 instruments, but really we're trying to see the sky in all wavelengths. What are the challenges or the issues here? So what we're trying to do in the end is we're comparing or fitting models of some sort of source emission, spectra, shape, and so on to data that's been measured. There's 2 basic approaches you can take. Either you can try and unfold the data, so removing all the instrument effects and trying to get back to something like a differential flux measurement, which you can then compare between instruments and also can compare your model directly to this measurement. This has some issues because when you're unfolding, you always have to put in some assumptions on the source size or shape, on the spectral shape, and these are not always consistent between instruments. It can also be difficult, especially when combining data, when you have weak sources, some instruments that maybe didn't detect anything and are contributing upper limits. So the uncertainties are very non-Gaussian, and that can cause issues with the fitting. And last but not least, when you're combining data from instruments that have different angular and energy resolution, it can be challenging because potentially one instrument could resolve multiple sources, while another one may not be able to do that. The second approach is to, instead of trying to unfold the instrumental effects from the data, forward fold the model. So from the model, calculate the predictions for lower level data, such as photon counts per energy plane or something like that. And then do the fitting in this count space. In that case, the model assumptions are always made explicit. But the problem is that when you're trying to do multi-wavelength analysis, that you need to deal with data that comes in very different format from different instruments with different file formats, different internal formats for the data and instrument response files. I'm going to talk about this second approach, the forward folding, from now on. There are several different packages that do this. They all have slightly different approaches. There's probably more, so I'm mostly focused on the gamma ray side of things because that's what I'm personally interested in. There's probably others that I'm not aware of. For the gamma ray specific ones, I also encourage people to check out the poster and the BOF sessions that I mentioned here on the slides. I'm going to talk about, like I said, 3ML, which is a Python-based program, which depends on the scientific Python packages and is able to read in data from different instruments in their native instrument-dependent format. So the workflow of 3ML is that we're doing this likelihood fitting. So we're starting with a model and then some starting values. This model is then handed to different plugins for each different instrument that you want to use data from. The plugins do all the heavy lifting. They calculate the predicted, they read in the data files, they convolve the models with the instrument response files, calculate predicted counts, calculate the likelihood. In the end, all the likelihoods are handed back to the minimizer, just combined, and then the minimizer decides where to step through, how to change the parameter values, and try and find a maximum in the likelihood, which will then give us the best fit parameters. And this is set up in a very flexible way so that all the data specific stuff is encapsulated in these plugins. For the modeling of the astronomical sources, we're using astromodels, which is also developed and maintained by the same developers as 3ML. An astromodel's model can contain one or more sources. These sources can have a spatial shape or it can be point sources. They can have spectral components, one or several, optional polarization. The shape can also be energy dependent. We provide a bunch of different functions that describe commonly used spectra or shapes. You can also have functions that are physical shapes, physical spectral shapes. by wrapping around other modeling programs. And users can also easily provide their own functions. Astro is also able to link parameters between sources in a very flexible way with arbitrary functions, and everything can be streamed to disk in YML format. It also supports time-dependent parameters, and there's some convenience functions to generate models from external catalog, for example, the FGL catalog of gamma ray sources from Fermilab. So how does this forward for likelihood fit now work? So the mathematical basis of this is just the Poisson likelihood, right? So we have some expected number of counts that is given by a model, convolved with the detector response function, of course, and potential background counts, estimate of the background counts that you may get from data or also from the instrument response files. And then we have our observed photon counts. And then this data is typically binned in pixels on the sky, energy bins, and all these measurements that were independent, so you can just combine them by multiplying the Poisson likelihoods. And if you don't have an imaging instrument, you just don't do you just have one pixel basically. And then same way, the measurements from different instruments are independent, so you can just multiply the likelihoods from the different instrument. And then we typically use likelihood ratio tests, where the equation is given below, to compare different models, for example, to measure the significance with which we detect a certain source or a spectral feature. The plugins, like I said, they do all the heavy lifting. Currently, we have plugins supporting Hawk gamma ray, the Hawk gamma ray telescope, which is the TeV instrument, Fermilab, which is a GeV gamma ray instrument, FemiGBM, Swift XRT, and all OGIP compliant instruments, and then Polar, and also some plugins for general photometric data. Or you can provide general spectral density or spectral flux points with chi-square likelihood, so you have to make sure that that your uncertainties support that. Some of these plugins are wrappers for external software. For example, there's a Fermilab plugin that just calls FemiPy, just the official, which is an official Fermi software tool. Or some of these are also standalone. There's also some more plugins that are in the works. You can see an example on the right for a visualization of what some of the plugins do. So you can see there data in the KV band from several instruments, and then the model predictions. And this is done in count space. So you can, the spectrum model has all the instrument response already taken into account. Plugins also have a few more functions other than just calculating likelihood. For example, they can from a given model, you can use a pseudo-random simulated data set, which can be used for things like sensitivity calculations or a likelihood ratio test. And then some, like the one shown here, some plugins also have visualization functions or the ability to download data files that they want to analyze. There's some more features that Fermilab has. So for the likelihood fitting, we actually support several different minimizer measures, both global and local. They are, again, also realized via plugins, so you can also easily rate a plugin for an external minimizer like you'd like to use. And then in addition to likelihood minimization, we also support this, we also support Bayesian posterior sampling, where you either MC or multinest. And for this, the user would have to provide the Bayesian priors, of course. Then there's some more classes and functions for plotting the results, saving the results to disk and reading in previous fit results. Like I said, you can make these pseudo-random data sets for things like goodness of fit calculation or sensitivity studies. And we also have some functions to propagate statistical uncertainties and derive parameters, including correlations. So the current status is that Fermilab, like I said, it's a robust and flexible framework for multi-wavelength data analysis that's being used for analysis from Hawk in the TeV gamma down to many other wavelengths. It's active development. There's some more plugins that are being worked on, and we recently got everything Python free got everything to support Python 3 now. If anyone is interested in using 3ML, please check out our documentation page for installation instructions and tutorials. You can download 3ML industrial models on Conda or PyPy. If you have any other questions, please ask me now. If you want to see any examples, ask me now, or also come talk to me on Discord. And I kind of forgot to say on the first page, but I'm presenting this on behalf of not just myself, but also my collaborators and a bunch of other people that are not on here that have contributed to 3ML in the past. So I'm going to leave you with the names here.
Thank you very much. Great talk. Do we have any questions from the audience? Here we go. One came in. About 3ML. Oh, it's a long one. If you use individual count information for the fitting, does this mean that if you are simultaneously fitting, say, X-ray data together with optical data, you need to provide some sort of event file for the optical data, where each count has an arrival time and energy? This seems unfeasible, but I might have misunderstood.
Now, for the optical plugin, I think it just supports magnitudes. Also, the time dependence, we typically we typically use time integrated counts. If you want to do time dependent, you would do it in time bins. But for the optical plugins, it's they just use magnitudes, I think. For gamma ray and X-ray, where it's more feasible to get the to have the actual counts, because the number of photons is just less. But that's mainly where we use this, and that's also where the angular resolution and energy resolution and so on are much worse than for the optical, and that's where this really comes into play.
Thank you. And we have another one. Is there any work going on including New Star?
I'm not sure about that actually. I can try and get back to you.
It was Sonal Patel.
Sonal Patel. Okay, I will try and get back to you and find out what's going on with that.
Okay. Actually, I had a question. The plugins, are people able to write their own plugins? So if somebody came in and said, I want to write plugins for this,
yes.
Is there documentation and process?
Yes, there is some documentation. I think there's one tutorial on the webpage also that works, that talks about that. The documentation is not in all cases as thorough as we would have wanted, but there's definitely documentation. Some of the plugins, for example, the Hawk plugin is a standalone package. Hawk Hell that we're using right now is a standalone package that was written though by people that were also involved with the 3ML. So if someone would like to write their own plugin, that's perfectly possible to do so, and they are also welcome to contact us, me and the other developers, and ask for pointers.
Okay, thank you. And let's run the applause. Okay, let me just deal with. Our next speaker is Brigitta Schiputz, and she will be talking to us about Astro Query. So you can unmute yourself and share your screen, and I'm going to give you the spotlight. Oh, spotlight.
Do you see my screen?
I do, yeah. I think we're good to go.
Okay, thank you very much. So my name is Brigitta Schiputz. I'm a direct fellow at the University of Washington. I'm a member of the data engineering team at the Dirk Institute, lead developer of AstroML. And as many of you in this room, in this conference, I'm an astronomer by training, but over the years, I moved more towards software. I figured out I'm more interested in this software and became a research software engineer, basically. And I'm spending most of my time developing and maintaining community open source software, mostly in the AstroPy ecosystem and also in the scientific Python ecosystem. And I have a very strong interest in building sustainable infrastructure for this ecosystem to support all these packages and science. So I would start with a non-controversial statement that Python currently is the most popular language for astronomy. And this trend is especially true for user scientists. And one of the main reasons, one of the many reasons for this popularity is the vast ecosystem of available scientific libraries, and most of which is built on the open source philosophy. And there are plenty of open source astronomy software existing, but code dumped on the internet is not open source, and also open source shared code is not really open development. But what really driving factor for community building and the success of AstroPy and all the ecosystem is this open development model, which is also building a community, not just the software. So what do I mean here? It's mostly about making decisions out in the open, having the implementation details available on GitHub and open for the community to give input and contributions, code contributions. And the feature implementation is driven by individuals and sometimes institutes, but there isn't a central place that driving this development. And most of this collaboration is done remotely with a few face-to-face meetings peppered throughout. So how does this come to my talk about AstroQuery? Well, AstroQuery is one of the success stories of the AstroPy ecosystem. So a summary about this ecosystem, AstroPy is not just a core package you all use with import AstroPy, but it's also a much wider ecosystem of coordinated packages, which means that the same team ensuring that maintenance will be kept even if maintainers are moving on with their life and leaving astronomy. It also consists of infrastructure packages that has nothing to do with astronomy, but that's necessary for all these other science packages to build upon. And also a large collection of affiliated packages. These are usually peer review packages with a very focused science interest. So where does AstroQuery fit into this picture? Well, it's one of the coordinated packages of AstroPy, and it builds very heavily on the infrastructure of the infrastructure team puts together. So this slide would just give you a summary of AstroQuery. So it's a coordinated package. It's a collection of tools to query astronomical web forms and databases. Currently, it's grown enormously in the past few years. We have currently more than 50 modules to access archives, catalogs, simulations, line lists, ephemeris service, and other services as well. So it's not only archive data access anymore, but much wider collection of services. And one main thing here is that it will always remain independent of the core AstroPy. The reason behind it is that because it relies on remote servers we have no control over, we can't really guarantee backward compatibility. So it can never really land in the core AstroPy package. And also, partly because of this reliance on remote servers, we operate in a very different model than the rest of AstroPy, namely that we are continuously deploying AstroQuery. So after each bug fixes, a release will be available on PyPI and for the users to update and reinstall easily without the need of going to GitHub and installing the developer version. But we also keep a few manually tag releases a year for packaging and maintenance purposes. And now a brief history of the success story of Astra Query. It all started from the user's perspective. So this is where it differs a lot from other approaches. So it started with the user's desire to have a reproducible and easy to use access to their data from Python. Typically, these were observers wanting to download their data, access a catalog, and they wanted to do it again and again and reproduce their workflow from a script. So one of the main desires were to reproduce what was available on the web form. So it was really just a tool to circumvent clicking on a web browser. But then the vision from early on was to converge to a common uniform interface for users, using the same method names and the very similar structure and layout for all the archives, which might have a different web experience for the users. The Astra Query over the years grew successfully and became very popular with users, mostly because of this very ease of use. And part of that story is that the modules are developed independently. Some relied on web scraping and reverse engineering, but right now we have more reliance on APIs and VO for the backend while keeping the similar user interface. And as it became more popular with users, the archives also, many of the archives also came on board, and they drive the development and maintain several of the modules. We also have some traffic data from some of the archives who report that a significant fraction of the traffic is coming through Astra Query. And now a few words about the team behind Astra Query. There are 3 volunteer maintainers. Clara is also attending ADASS. Adam is setting up. So it's the 3 of us who are trying to keep it together, doing code reviews and the general maintenance. In addition to the 3 of us, we have over 130 contributors over the years, over the last 8 years. And these people include data consumers and also data providers. So here is a graph that shows the number of committers, so the number of different people in a bin for 2 months, every 2 months. So it's easy to see on this graph that in the early days, it was driven by a constant flux of typically users and interns we mentored. And starting around 2017, observatories and archives started to come on board. So we have more engineers and archive scientists contributing. So it all started, as I recall, with EasySky and MAST. So those are the first 2 modules that were developed by the archives themselves. And a tiny bit more about the Astra Query community. So it's right now it's a mixture from individuals and institutions. There are a few more modules in the work, but there are still a few archives missing. We also published a paper in AG last year, and the paper, or Astra Query as a text, is mentioned and cited already a lot of times based on ADASS. And so what does this growth mean for Astra Query? Well, we have more users. That means that we have more reported issues and more requested features. We try to keep up with this. So this is the central figure. But the open, so while we are working to close and address these reports, there is a growing number of still open ones. And as there are more users, there are also more contributors with pull requests, and all those pull requests needs to be reviewed. So right now, I think it's fair to say we are balanced. We are at the limit of our resources, but to provide more growth, we need more resources for maintenance and or more coordination. And here I would suggest a few avenues to do this, and would welcome a brainstorming session to talk about how to proceed. So one way to grow the developer community is to do internships. We did this for a couple of years, and it was quite successful. And early on, programs like the Google Summer of Code gave a large boost for AstroQuery, and especially for the inner workings of AstroQuery, not on the module level, but the very generic structure. And this year, we also run an internship with Outreachy to overhaul some of this infrastructure. We also know about interns working at institutes and working at archives to contribute to those to their modules. These interns are not mentored directly by the AstroQuery maintainers, but we are collaborating with them. And the other way of growing this developer community is to provide avenues for meetings where the meetings goes beyond the common science interest. A few success stories from the past is, for example, Python Astronomy, or the IBOA meeting, which I think last year was very effective. And we could also run sprint events, which happened at a few conferences like SciPy, usually in person, but it can also run online.
2 minutes.
And thank you. And then the discussion can go on our mailing list or developer forums like Slack. And to kickstart these new channels of communication, we started community calls. We had the first one a few weeks ago, focusing on our outreach internship applications. But the aim here is to make it a regular event following NumPy's model. So it will be a developer, contributor focusing event. So I would like to measure whether there would be interest from you. And also, it was in the plans to have this autumn an AstroQuery workshop at UW. So we will revisit this idea once we are over this pandemic. And if there are any other ideas or suggestions, let's brainstorm about this. I think ADASS is the perfect venue to do this. So I would like to suggest to open a channel and chat there, either in text or in a call. And to summarize the key points about collaborative software development, we don't necessarily talk about this a lot, but I think these are very key points behind the success of AstroQuery in this case. And yes, with this, I would like to take your questions.
Thank you, Brigitte. I will allow one question because we have run out of time. So I'll get that question. What are the prospects for implementing queries for astrometry of unknown small bodies? For example, MP checker from Minor Planet Center or SB identification from GPL. If nothing is planned, how can people volunteer to help build them?
Okay, so we have a couple of minor planet-related modules already. All of these were developed as part of a grant went to SB Pi. And as far as I know, there are still plans to do more development. There is an open issue on the AstroQuery GitHub, so I would suggest to you to join the discussion there. There is a checklist of what other services they are planning to implement themselves, and I'm pretty sure that more contributions are welcome. The only ask is to coordinate. So I will post the links to that issue on Discord.
Great, thank you. Thanks for the talk. And our next speaker is Francesco Pierfederici, who will explain to us how to organize such a conference. I guess you can unmute yourself and do everything, Francesco.
Yes, I guess I can manage. Thank you, Kathleen. I guess you can see my slides.
Yes, we can.
Awesome, fantastic. So, well, I'm showing what you would have seen from the venue had the conference been in Granada. We are all very sad, but hey, what can we do? And I'll be talking a little bit about that. It's a little bit of a change of gear with respect to the previous talks. So I'm sure you will find it interesting. Also, I meant this talk to give a little bit of, you know, some concrete, practical, and actionable advices to any event organizers out there, whether or not you're organizing a big conference or a small workshop, whether you're organizing an online event or an in-person event. So I think there will be a little bit of for everybody, and you'll get a glimpse of what we have been working on this years. So let me get to the next slide. This is just for posterity, just for people watching on YouTube in 10,000 years, assuming that there will be YouTube, and they can know what ADASS is about. We all know about it, so I will not spend much time on it, or any time at all. So we started working on ADASS 2 years ago. Mike and I were sitting in Santiago de Chile in front of a number of beers, and that's when we decided, you know, why not Granada, and came back and I started working on it. I started recruiting people, some very innocent souls like Jose Enrique, who you know, said yes without thinking too much. And you know, things were pretty much underway when the whole COVID-19 thing exploded. It was clear that we could not hold an in-person conference. And then we had, you know, some pretty difficult decisions to make. So one first thing of advice that I want to give you just now is this. If you're organizing an event that needs a venue, any venue, small or large, start early, especially nowadays. If we were able to hold an in-person workshop or conference, we would need a much bigger venue than we would need normally, because we would need to keep, say, 1 to 2 meter distance between people. And these venues, large venues, very large venues, there are not that many, and their calendar fills up very quickly. So in this day and age, you probably will need a much larger venue than you think. Start early. Now, when things change, you're thinking that you're organizing something and you end up organizing something different, like it happened to us because of this pandemic. You can cancel. Many people have been there before us, and some people decided to cancel. Totally understandable and totally respectable. You can postpone. Lots of conferences around the world have postponed to 2021, in some cases 2022. Again, very respectable and understandable. We decided to go online as many others, and that had some non-trivial implications, and I would like to draw your attention to some of those. Not only we had to undo everything that we had done, but there is a couple of wrinkles there that is good to be aware of in general. So if you're organizing an event, you will be probably having to sign some contracts. And before you sign on the dotted line, there will be a lot of people who will be posing as your best friends and telling you things like, don't worry, or things like, we are partners, or things like, oh, we are all reasonable people. That's not true, okay? No, that's definitely not true. Once you sign something that they will enforce. And this is something to keep in mind, whatever you do. Always read those contracts. They're built so that you don't read them, right? They're very small fonts and language that is very hard to understand. But make sure that you can get in those contracts some cancellation clauses that are favorable to you. I know some conference organizers that were hit with cancellation fees of the order of the price of a very nice car, okay? We were lucky, not everybody was lucky, even in this situation, right? Now, one other thing that I want to say is that the format of your conference determines not only your budget, obviously, right? An in-person ADASS would have been significantly more expensive than the online ADASS that we are participating in, because you have to pay for a venue and the catering, which is easily 90+% of your budget in the case of an in-person event. But also, and probably more critically, or just as critically, changing the format of your event will also need a change in the skill set of your LOC, of your organizing team. Say you're organizing a bigger workshop, and then because of the fact that people are afraid to travel, you have to organize a much smaller one. Or maybe you're organizing an in-person event and you say, you know what, it's nice to have also people being able to participate online, so I'm going for a hybrid event, right? In all those cases, or our case, in person to online, the composition of your LOC should be carefully considered and realigned with the new format. In our case, we didn't have the time to do that. We started with a LOC that was great for an in-person event where you have people of all types and all skill sets, and you need people to physically go to places and physically talk to people and look at menus and press the button on the projector to see if it works and all that kind of stuff. With a online conference, you basically only need technical people. It's an exaggeration, but you mostly need technical people who can run servers, you can, set up databases, query databases, and all that kind of stuff. In our case, we were not able to realign our LOC, and that meant that some people, 3 people in concrete, bore the brunt of the work to organize the conference. It can happen, but just be aware of that. The other thing that I want to say, and this is something that we are experiencing, all of us, right now with this online conference, is that we were looking around, like crazy to find platforms and pieces of software and tools that we could use to run an online conference. And at that time, there was simply no unified platform that we could use. Right, it would be nicer for all of us to have a nice single interface with, very coherent interface with the video and the chat and everything integrated. We couldn't find anything. And my feeling right now, November 2020, is that that is still not the case. There are a couple of very promising candidates. I think next year we'll see some great platforms out there, but I'm afraid we're still not there. From an organizer point of view, the situation is even a little bit worse, because if you're not set up as a company, if you're not set up to receive payments, and your institution, in our case, our own institution, the two institutions here in Granada, if your institution are not set up to accept credit card payments, that was the case for us, then you have to rely on a third party, on an external company, the so-called technical secretariat. And communication with these people could be challenging. It was challenging for us. Their infrastructure is, well, still relying on, lots of manual work. Every time at the beginning, every time one of you was registering, we would get an email with a PDF that I had to click, and copy, paste, click another one, copy, paste. And things have improved, but still the two databases, the two worlds don't really talk to each other very well. Also, sometimes it's even difficult to actually talk to these people because they live in a different world. We are living in the world of databases and software. They live in the world of banks and credit cards and that kind of stuff. So, yep, sure, thanks. Online conferences, however, are very positive. They have very positive sides to them. They are cheaper, which means that the tickets are cheaper, which means that more people can attend who could not normally afford to register and travel. Also, they're online, so you can watch them asynchronously from wherever. That also allows more and more people to join and to consume this type of content. You get almost free video recording for the talks. There's not like Lord of the Rings quality, but it's pretty good. And that also allows you to publish those links to the wider community, as we are going to do. Still, not everything is fantastic. You still need to use tools, online tools, computers, pieces of software. That can be intimidating, can be also alienating part of the community who find the software to be awkward to use. There are privacy concerns, so we try to address some of those with the choice of the tools, but there's only so much you can do at this point. As I mentioned, it would be nice to have a nicer platform for attending and organizing. And nothing beats drinking beers or wine or coffee with your friends and colleagues. I leave you with just this slide. We have almost 600 participants this year. Pretty good result. Lots of volunteers helping run the conference, chairs, room managers. A lot of people have stepped up. A lot of people are also helping on Discord, answering questions and stuff like that. We have a large number of posters. We're still thinking how to maybe organize something for posters. We'll see. And I think it's shaping up to be a pretty good conference. So enjoy the conference, and I'm happy to take any question if there is time and there are questions.
Thank you, Francesco. I guess you want me to read? Let's do it properly. So, question from Rob Seaman. I have attended other successful meeting during the pandemic, and there will be SPIE next month. Do you think ADASS has reached new groups of people due to going online?
Well, Rob, first of all, nice hearing from you. Long time no see. I think so. We have seen people from also, not rich countries joining ADASS online, also because of the price for sure, and also the fact that we are not that far because we are on a computer next to you. So I think so. I think the positive of an online event outweigh the negatives. And so I would suggest people consider an online portion also for a in-person event.
Okay, thank you. In the interest of time, we'll leave it here, and we're going to move on to the... So we're going to move on to the focus demo by Oleg Smirnov. And I can see the interface here for me is different from Oleg. Oh, here, there's another one. Okay, so we can see him. I'm gonna give you the spotlight, and it's going to be about the Radio Padre. And you're given the spotlight now, Oleg. You take it away.
Thanks. Is my microphone working?
Yes, it is.
All right, then I will share my screen. I presume you see that.
I can see it. Yep.
Okay, cool. So in the POC this year, there was some grumbling that a large fraction of the submissions started with the phrase about the coming deluge of data in astronomy. And I think we were even threatening to introduce machine learning algorithms to deal with this. So I thought I would immediately take countermeasures. And if I'm going to talk about the deluge of data, then I might as well talk about it in Old Testament terms. To defeat your machine learning algorithms, and I call it my GAN, Googling about Noah. Chair, can I have a canned audience laugh track, please, at this point? Anyway, I don't actually want to talk about the deluge of data. What I want to talk about is how it has changed our working habits and what I'm trying to do about it. There's a picture here which I borrowed from my colleague Bill Cotton, who is also a rather Old Testament character. I think this picture has been up on his webpage since the first Clinton administration. And some of the people in this webinar are probably too young to recognize what it is on the picture. I think that's a DAT tape, right? We used to have that when we thought we had big data. So it's 3 a.m. Do you know where your data is? Well, I know where my data is. It's not with me, right? And we've gone through this process recently. We used to be very attached to our data. It was actually a reasonable thing to process data on our laptop, on our workstation. And now, well, I've come to terms to the fact that I'm separated from my data, which is really, on the whole, better for both of us, because data gets to hang out at the data center with other data, right? And I'm free to have a sleek and light laptop, which used to be great for traveling. Now I just get to sit at home and stare at it. But anyway, I think both me and data are happier with this. Some people still cling to their data. And in the days when we all traveled, you could recognize them. They had these big laptops with wheels attached, so that they could carry their big laptops around. And in the post-COVID era, I'm not sure how to recognize these people now. They're a bit of a dying breed. I suspect it's the people who keep their Zoom video link off because they're forced to reduce data in their underwear on account of the laptops being so hot. Anyway, for us, it's not an option. Meerkat produces 1 terabyte every 8 hours in the economical data regime, right? And 8 terabytes at full resolution. So it's completely impractical to keep the data on the laptop. Data has to be somewhere far away. And that means it's a bit of a regression to the past for us, right? Because we used to have data close, we could analyze it with GUIs, with tools. And now I'd like you to tell me, or tell me later, if you recognize yourself in any of this. So this would be my situation if ADASS was properly physical. I'd be sitting in my hotel room in Granada. Now I'm sitting in lockdown at home. I'd be on a crappy hotel Wi-Fi. And my data in my pipeline is safe. It's back in South Africa, but it's far away, far, far away. My pipeline run has finished. Maybe it's crashed. I got to diagnose that. I've got 300 log files, 200 plots, 50 FITS images, and a dozen HTML reports to deal with. And I don't know who I picked up this phrase from, but I like the quote that debugging is like playing the detective in a crime movie, except you're also the perpetrator and the victim. Well, when your data is remote on some computing cluster, then every debugging session is a post-mortem. So what I need to do is I need to make sense of the mess that my pipeline has made so I can diagnose things, change things, and start another run. But maybe my bandwidth is not so good. Certainly there's going to be network lag. Almost quite often, if you're not running your own cluster, or if you're not very good friends with the cluster administrator, then the software stack on the remote end is not going to have the stuff you need, right? It's not going to have your favorite FITS viewer. And anyway, you wouldn't be able to use your FITS viewer because of the network lag. So what we've done traditionally, like even up to a year or 2 years ago, in this situation, I would start an rsync session overnight to get some data products onto my laptop, pray, and then with the internet's blessing, maybe in the morning I've got downloaded enough stuff that I can look at it and diagnose something, and then maybe run my pipeline again. So Radio Padre is meant to address that. If you were in the BOF session earlier by Jan Nordum, he spoke a lot about users and developers. I don't think those are two separate categories. I think it's like, it's a whole spectrum. And we are all on the spectrum. At least that's what my girlfriend tells me. But I think it's actually useful to think in terms, not of developers, of users. It helps to think in terms of the caps we're wearing when we interact with our data, when we interact with our pipelines. And the first cap is what I call the power plumber. I'm sure many of you are familiar with this situation, right? You arrive at the scene, your pipeline has crashed, there is raw sewage dripping from the ceiling, God knows what happened. You've got no idea. You just have to roll up your sleeves, plunge in, and figure out what the hell went wrong, right? That's kind of the first cap. The second cap is what I call the Chernobyl operator. That's when your pipeline works reasonably well most of the time and things run smoothly, but every now and then there's a catastrophic meltdown. So you kind of have to, you want to be able to see everything continuously all of the time. So you've got this enormously elaborate visualization requirements. And then the third cap, that's the button pushing astronomer. And for the button pushing astronomer, of course, as a button pushing astronomer, which I strive to be, you want things to be as easy as possible. So quoting Einstein and my colleague Tony Willis, everything should be made as simple as possible, but not simpler. And Tony had some great words about the ideal user interface. So anyway, in a situation when your data and your pipeline sits remotely, then what tools do you have available to play these roles? The plumber and the operator will probably be using the shell, which is available everywhere, but it's not terribly productive. If you're lucky, you've got a VNC installation on the remote cluster. Maybe you can start a remote desktop. Maybe you can view some images. Once you've put a lot of effort in, you might have a bespoke GUI, or you might have a web interface, or your pipeline might produce HTML reports. That's sort of the solutions I'm aware of for this remote data problem. And what I suggest is that Radio Padre kind of addresses all of these roles in a rather simple way. So I think at this point, I should just start the demo. We'll wear our first hat one first, that of the power plumber. So basically, we're trying to troubleshoot the scene of the crime, which means we just want to plunge in and poke around. And I think you see my terminal now. Just to give you a taste for it, if I log into a machine where I'm conducting the demo, and I've prepared a little directory here, and you can see it's a mess of files, it's a mess of plots, and how do we make sense of that remotely? The machine I'm logging into is at the moment 1,000 kilometers away, so the connection is not too bad, but still. So what I'm going to do, this is now running on my laptop, Miles. What I'm going to do is I'm going to run Radio Padre, telling it to connect to a machine named Simon and go to this directory. And you can see it's established an SSH connection and popped up a browser. Now, the browser is running locally on my laptop. On the remote end, there's now a Jupyter server. There's something called Carta, which I'll get to later. So concentrate on the Jupyter server for a second there. And we can open notebooks, right? So let's open up a notebook. And you can see the notebook has just one command in it. It says from Radio Padre import ls. And ls is just basically, it's the only command actually you need to know in Radio Padre. And it means the same thing the Unix ls command means. It means list files, right? So if I execute this code cell, nothing happens. It's just an import statement. If I do an ls, I get a nice file listing. And I imagine most of you know how Jupyter notebooks work, right? There is Python code that I'm editing locally in the browser. This gets executed on the remote end, and the results get displayed back in my browser. And if the results produce HTML, then the output is rich, as it is here. So this looks just like a fancy directory listing. It is essentially just a fancy directory listing. What we can do is we can say, let's take this directory listing and let's take the first element. And The type of this object is something called the data dir. And the data dir works just like a list. So first of all, we can display it. So now we're displaying a subdirectory. And secondly, because it's a list, we can do all the usual list-like operations with it. We can take the first 10 elements, for example. We can take, let's say we take element number 28. And element number 28 happens to be a text file. And you can see when you display that text file in the console, what you get is an HTML output of the file. We can do all sorts of familiar things you would do with text files. You can display the head, you can display the tail. Another interesting thing you can do is the function call operator works with the same semantics as grep. So this says, I want to search for all lines containing info in this file. And you get them as the output. Right, and the type of this object is also a type of why does my clipboard not work? It really doesn't really want to work. So that's a text file, and the type of something that has search a text file is a numbered line list, right? So that's text files. Now let's look at something more interesting. If we look at something like, well, let's remember DD is our data directory. We display our data directory, and we see it's got a subdirectory number 4, diagnostic plots. Let's look inside there. And we see it has another subdirectory called crosscal. Let's look inside there. And we see a listing with a bunch of PNG files and a bunch of HTML files. Every one of these file names is clickable. So if I click on it, I get the web server to serve me the actual image. But I can actually do something even more interesting than just look at the directory listing. I can say, okay, give me all the PNG files in this directory. You can see the function call operator again has search semantics. And now that I have a list of PNG files, well, I want to show them as thumbnails. And I get all the 30 plots that were sitting in the subdirectory as a nice thumbnail display. And every one of them is clickable, pops up the plot in a separate browser tab. So that's all very nice for managing plots that your pipeline produces. Now going on to the next one. And these things are collapsible if you click here. So you can unclutter your display by collapsing the thumbnails. Going on, let's look again at our directory. You can see I've got a couple of fits files in here. So what I'm going to do is I'm going to say again, I can filter out the fits files a little bit by file name. And then I'd like to take file number 1. So I say, I take a variable, ff equals fits file number 1. And now I have an object that's recognized as fits file. And you can probably guess that there's many wonderful things you can do with fits files in here. Well, for starters, you can look at their headers. Now, a header is just a bunch of text lines, so it will actually have the same semantics as a text file. For example, you can search through it just like this if you want to look at all the history entries of the header. But even better, even more relevant for fits files, what you can do is you can, well, you can just show the fits file. If I say ff, something buzzes along, and what you see a little thumbnail rendering of the fits file. This one is, I'm going to saturate it a little bit. and zoom into it. So you get a nice, beautiful display of this radio galaxy, right? And these things are just optional arguments to the show method. Every object has a show method, which forces the object to be displayed as HTML. Keyword arguments modify the display. And it's also possible to actually set these things globally. There's something called the settings objects. And if I look at settings, they're also rendered in HTML. And I've got settings for FITS files. And what I can do is I can set the rendering settings globally. And this will have the same effect as passing them in through keywords. So another very neat thing about FITS files, you can see both here in the corner of the display and up here where we were showing them as a directory list, you've got these buttons labeled JS9 and C. And what they will do, they will actually open a FITS viewer for you. And there are two web-based FITS viewers that are bundled with Radio Padre. One of them is called Carta. And neither of these is my work, right? I'm just bundling them along with Radio Padre and they get installed. So Carta is an online FITS viewer. It gives you, well, the FITS image resides on the remote server, right? And all that gets shipped to my laptop are little PNG tiles to display this image. So this is nice and functional and slick and uses some very modern web technology. There's another viewer called JS9, which people are going to find probably familiar because it's written by Eric Mandel, who is also behind JS9. So it has a very JS9-like interface. Very different flavor from Carta, but also extremely powerful. I mean, you can do even stuff like, I don't know, 3D plots. I mean, oops. I mean, isn't this wonderful? This is running in my browser, right? And it's a FITS viewer with a 3-dimensional plot. And you get that pretty much for free with Radio Padre, right? You just click the appropriate button next to the FITS image in the file listing. There's some more stuff to see. There are specific things for radio astronomy. For example, if I look in the first subdirectory here called cal tables, I'm going to see a bunch of files which are what we call CASA tables. So I'm going to say, let's say, table is subdirectory 1, file number 7. And that's an object called the CASA table. And CASA tables are the standard format we use to store data in radio astronomy. So this particular table stores calibration solutions. And what a table is, it's kind of a lightweight relational database. So it's got rows, it's got columns. And if I display it, if I tell Radio Padre to display it, I just get a display of probably the first 100 rows in this table. The table is massive, so it's not going to display the whole thing. And of course, a table is just like a list. So if I want to display particular rows from a table, I can give a slice. This displays the first 10 rows. And I can even do things like queries. There's a query language implemented in CASA tables, which is accessible here through the function call operator. So for example, this looks up all rows in the table where the value of column antenna 1 is 1. You get this nice little output. And this, of course, is a list-like object. So if we can take the first 4 rows of that, we get this. And finally, so I imagine you're catching on to the fact that every file on your remote file system corresponds to an object on Radio Padre, and every object knows how to display itself. So you can actually ask all the objects to display themselves as thumbnails. And now you kind of get a mix of some objects don't know how to render themselves as a thumbnail very well, but other things like FITS files, PNG files, they know perfectly well how to render themselves into a thumbnail and give you this nice little display. And this is, of course, clickable again, right? You click on any thumbnail, you get the full plot in a separate browser tab. So that's it for Plumber mode, right? You can kind of quickly and interactively get an idea of everything that's happening on the remote end. A few words about what's happening under the hood. So this is your remote cluster. This is your pipeline. It's producing data products. This is your laptop. This is your SSH connection. The only thing you need to run this is an SSH connection, nothing else. If you have SSH connection to the remote end, that's it. What happens on the remote end, it starts a Docker or a Singularity container or a virtual environment. Inside that container, you've got your Jupyter server and you've got all the various processes required. There's a web server for Carta. There's a helper process for JS9. And this is what's rendering your data products. These things, of course, they expose ports, which Docker or Singularity exposes on the remote end. And these things are port forwarded through SSH into ports on your local laptop. And you're running a browser. There's a JavaScript virtual machine in the browser. And in the JavaScript virtual machine, you're running the JS9 GUI or the Carta GUI. And this talks to the ports forward to over SSH. The result is hopefully a happy user. This thing is practically zero admin. The only thing you need on the client side is Python SSH in the browser. And on the server side, you need either Python with Docker or Singularity. And then it downloads containers of Docker Hub and runs Radio Padre in a container image. And that's kind of guaranteed to work anywhere. Or the more lightweight version, if you've got Python 3.6 and virtual env, you can run Radio Padre in virtual environment mode. That's kind of more lightweight than a container, but not completely guaranteed to work on every system, right? Because as you know, in a virtual env, you depend on the native libraries. I'm giving you a link, but you should be able to just Google for this. And in principle, this thing should be remote installable by the user on a naked server without root privileges. So I can show you, I've got another machine called Garfunkel, and this one doesn't have Radio Padre installed. So when I run Radio Padre locally, it tells me, okay, there's an error, try rerunning without init. And if I do that, you can see it goes off and creates a virtual environment on Garfunkel and starts installing. And that's going to be a bit of a story. I don't have enough time in the demo to wait for the installation to finish, so I'm going to interrupt it. I'm going to go on to the next subject, which is our second head, the Chernobyl operator. And radio interferometry is a good example of this, right? Because in radio interferometry, we have a very long path from raw data to our science radio data products.
Oleg, I'm sorry to interrupt. You have like 5-6 minutes left.
Yeah, I'm keeping an eye on that. So I'll do a quick demo of this and then I'll stop. So we have a very long pipeline which goes through many stages, and lots of things can fail along the way and fail in very non-intuitive ways. So it's absolutely essential to have intermediate diagnostic products if you're going to figure out what went wrong. And if you've got a mature package or a mature pipeline, then you know your likely failure modes. So you can, you can get a postdoc or a PhD student to write some code that will render a neat HTML report and show you all the things that you need to see. But if you've got an immature package, then you don't really have a choice. You need to leave all the guts hanging out, because when it inevitably crashes, you want as many clues as possible for your postmortem. And this is kind of what I call the death by information syndrome, or the Chernobyl control panel syndrome, because yeah, you can make 400 plots, but what's the point of making 400 plots if you can't, make sense of them, especially when you're talking to the cluster over the network and you've got network latency and all that. So in my remaining 4 minutes, I'm going to show you that it's actually very simple to make Chernobyl control panels with Radio Padre. You can probably make one in 4 minutes. I'll use the Caracal pipeline, which you can see in a poster by Josh in this conference as an example. So let's see if I interrupt this connection. Again, I'm connecting to a machine called Simon, and I'm going to directory called projects. And that loads up a little, very simple notebook I've made, which you can see it just does an ls and lists IPython notebooks in subdirectories. So if I run this thing, this is kind of a very convenient starting off page for me because it shows all the things I'm actively working on, including this project, which you can see has had a lot of trial and error. But I want to take you to this notebook here, ADASS demo, standard progress report. And so here's a notebook. You can see the notebook is actually very minimal. It only has a few code cells. And if you look closely at what's being done in these code cells, again, all I'm doing is I'm calling the ls function and asking for thumbnails, essentially, not much more than that. And I'm basically here, I'm relying on the fact that when the pipeline runs, the pipeline follows certain naming conventions for the directories and for the files that it produces. So just by specifying specific file name patterns, I can match those up to products that I want to display. So if I run this notebook, what I get is, well, here's some preachy stuff at the beginning. Then I get all my log files here, arranged most recent to least recent. Here I get all the diagnostic plots that the pipeline has produced. They are nicely collapsed because otherwise I would be completely overwhelmed by them. And in fact, I think my browser is overwhelmed by them because I'm trying to uncollapse them and I don't see anything. And also I can hear my fan going, so this will teach me to run this on a thin and light laptop. Anyway, I can see I'm about to run out of time. And as you know, the first rule of live demos is never to do live demos. So I think this might be a good time to stop. I'll try to reload this, maybe it will display. And in the meantime, I'll take questions if you have any.
Thank you, Oleg. Yes, there is one question. Can you take values out of the fits image or CASA table rows and do, for example, computations?
No, of course, right? Because this is a standard Python notebook with just some extra functionality on top. So you can have cells that do whatever Python you like, right? It's that's the beauty of it. You're talking to a Python interpreter on the remote end. You can import AstroPy, you can import Matplotlib, and you can do basically whatever you want with it.
So you have full access to those files.
Yeah, completely full access to those files, right? It's a Jupyter notebook, so it can do anything a notebook can do, anything that Python interpreter can do.
Thank you very much. That was a great demo. It sure piqued my interest. I have a few notes. And
thank you.
Thank you. And let's run the applause. Thank you very much. What's coming up next is a BOF, and it's about how to better describe software for discovery and citation. So Peter Tubin, Alice Allen, and Bruce Berriman will be leading this session. They will have they have co-host privilege, so they'll be able to bring up panelists. And so I'll be there to assist. But Peter, I see you're ready, so take it away. The floor is yours.
Thank you. Let me share the screen. I put a link to the slides. Oleg is still there. I put a link to the slides in the special Monday BOF chat session. That didn't work. I think I fixed it. If somebody can check that and let us know, but let me share the screen anyway. I don't know what this is. I'm seeing a funny screen in front of me. 1 second, guys. I have many overlapping windows. There we go. All right, is that visible? Now I see many more people in the window, so that link probably worked.
It's visible.
Great. Well, I'll do the presentation mode, see if that works. All right, is it now in full screen?
Yes, it is.
Yeah, great. So here we are, how to better describe software for discovery and citation. And we've talked about that in the past many times. We're talking really about software metadata. How can we describe the software, and what is actually the software metadata besides, you know, your tar, your zip, your GitHub repo that you have somewhere. This is what we're planning to do. We should have a little fun session today. We have prepared 7 little sessions of about 5 to 10 minutes each, and that should take about 45 minutes or up to. After each item, we will stop for a second and see if there's any discussion. I would suggest we use Discord. I've already seen earlier today, it's quite challenging to keep up with the Q&A and Discord, but I have people that can help me with that. So just interrupt me when I don't see something that we have to have somebody take the word. And then at the end, for the last 45 minutes, it'll be an open floor. I hope that some of our items will incite you to some more ideas, and then we will write them down and see what we do with that. So first of all, Scott, why do we want to do this session? Boom, there we go. Apart from being, you know, a generic Google, where is what code and what can it do, there are registries like the ASCL and Zenodo, where you can search for your software. You can find it in ADASS these days. You could rely on your noisy Google. But what we want to talk about today is the concept of how do we do this in the metadata, and what are the metadata. There is a link that I gave there by Spans that has a lot more background about making software findable, and it talks about these metadata. But we start with an example of how we can cite software in an example in Montage. And then the next slide, I think, I will give the screen over to Bruce. Now, Bruce, are you going to just tell me when to advance, or how do we do that? We actually didn't test that.
Okay, the simplest thing would be for me to just tell you when to advance.
Sure, go ahead.
So, advance. Thank you. All right. Well, I was getting really desperate for entertainment during the pandemic, so I decided about a week ago to try an interesting experiment with Montage, which, as you know, is my software for creating image mosaics. It's been out in the wild for many years now, so I figured with all the work we put into it, all the metadata you need for software discovery and citation is readily available. So I went to the site as tool, this URL, you can see at the top there, put in the URL and let it search for the metadata and see what happens. So next slide, please, Peter.
Mm-hmm. Are you going to tell us what the metadata is?
It will come up.
Do I have to do another hit? What's going on here? Yeah. One more?
Yep. Okay. This was very interesting. It gives you the citation at the bottom. It also apparently brings up the American Psychological Association, which is a bit of a mystery to me. Maybe it's a comment on my state of mind during the pandemic. I don't know. Next slide, please.
So that came up.
Yeah. Okay, so this is screenshots of the output from CET, and I'm going to go through them. It'll be, I think, the next 3 slides and see what it found. Well, it found okay, back to the previous one, please. Right, found the web page. It did not find a site as relation header. It didn't find a DOI, even though we do actually have one. It didn't find an archive page, although we do have one of those as well. Next slide, please. It did find the GitHub repository. It didn't find the DOI in the GitHub page because it's not actually there. It's on the main web page. Again, in the GitHub, it didn't find a code meta file because honestly, I've never created one yet. And it didn't find a link to a citation file because I never put one there. It did find a README file, which I think does contain some of that information. Next slide, please, Peter. All right. Again, didn't find a DOI in the README. It didn't find an R description file, but I don't think that's necessary for montage. It did find a API response, and it did find citation metadata. So this kind of shocked me to some degree. We've been working on this a long time, and quite a bit of the information that you need to cite and discover the software isn't there. So there's clearly work for me to do in that regard. So the next and last slide, please, Peter. So the question I set to myself and to us is, what are the recommended best practices in this area of creating metadata, data discovery and citation that software providers should be using? And I hope that we can be discussing this during this BOF. All right, so that's the end of my slides, and thank you for advancing, Peter.
Okay, you're welcome. And I want to again refer to Spaan's paper that I presented in Why We Do This Session, the Zenoda URL, where you can find a lot of background of some of the stuff that you see in the ADASS. So the next item is number 3 on our list, creating software metadata files from the ASCL entries. Because as you know, we have an ASCL registry. And it's no coincidence, perhaps, that the 3 speakers in the BOF are related to the ASCL. And Alice is going to tell us what she has discovered, or the services that she provides to help you with metadata.
Yep. So if you could advance to the next slide. I'm so glad that Bruce did his exercise and asks the question, because one of the ways that you can get your software cited correctly is to tell people explicitly how you want it done. And there are 2 metadata file formats that are now becoming very popular, or at least getting increased uptake over time for doing this. One is codemeta.json, and the other is citation.cff. These aren't the only ones out there, but they're the 2 that the ASCL creates. And as I said, they do have growing adoption, not just in astronomy, but also in other sciences. So if you, and obviously, CiteAS looks for these files and didn't find them on Bruce's site. So have we got a solution for him? So if you could hit the next, advance the slide, please.
But let me ask you a question. I remember that there's sort of the same thing in the same file, which is kind of confusing for users. Should they do both, or do we do this cross-walking thing, or are you going to talk about that particular issue?
I'm actually not going to talk about that. What I'm going to say is that these are two files. Citation.cff is only for citation. That it was made specifically for that. It's a YAML file, so it's in markup that's easy to read and easy to produce. CodeMeta is in JSON, is a little bit more complex and includes more information, including the citation information. So there is more that you can do or get into and out of a codemeta.json file. And both of these have been crosswalked to other schemas, such as schema.orgs. As a matter of fact, codemeta.json takes fields from schema.org, uses them, and then has added 10 additional fields that schema.org did not have, that better describe software. So it was a deficiency in schema.org that was seen, and the Code Meta project started to try to fill in those blanks. So there's plenty of information. Those are both links. So there's plenty of information at those links and on the ASCL, and a workshop that we did a year ago that I can also link you to if you're interested. But what I really want to focus on is these are easy to produce if your code is in the ASCL. And even if it isn't, you can get a sample file from the ASCL that you can then edit for yourself. And that's what I want to show you. You don't need to go through the pain of learning how to do these on your own, because we've already gone through that pain for you. So go ahead and advance to the next.
Okay, here we are.
So these are metadata files on demand. All you have to do is add codemeta.json / codemeta.json or / citation.cff to an ASCL entry URL. This works only for codes that we've accepted, and it works only on the numbered URLs, the ones that have the ASCL ID embedded in the URL. These are intended to be a starting point as a help to the user, as a help to the code author, so that you can take these and put these on your own repo so you don't get results like Bruce got when trying to use cite as, because cite as does look for these. So go ahead and go to the next one. Next slide, please.
Yeah.
Thank you, sir. So here's an example. We use Nemo as the example. Don't click on that link. I'll show you on the next slide.
Oh, okay.
I don't want to do the live demo here. You guys can do that on your own computers. So just go to the next slide. So that's what the URL looks like with the addition of the / codemeta.json. So this is all collapsed. You can hit enter one time, please, Peter. So this is all collapsed. So you can see what fields are there. We include fields that we don't have, such as license, because we want you to add that information to the codemeta.json file. That makes the file much more useful. We know from this morning's session the importance, or from the earlier session, whenever it was and whatever time zone you're in, how important the license is. A license lets other people know what they can and can't do with your software. And we encourage authors to add a license to their software. And if you create a code meta file, please include that. So you see that there are placeholders here where there's information that we don't have. Advance, please.
Yep. Yeah.
So here you see that the citation that Peter has specified, or that the code authors for Nemo have specified, is a link to a paper. We actively seek out the preferred citation. And when I say preferred citation, I mean preferred by the code author. We want to include the way you want your code cited in a.
Oh, am I dead or is Alice dead?
Will show that. If you don't list a preferred citation when you create this file, we will just by default put in the ASCL entry URL saying cite with the ASCL ID, but we're not, and that's simply to put something in there. What we want you to do is put what you want in there. And if we don't have that information, please tell us what it is so we can add it. Go ahead and advance, please. So let's look at an example of citation.cff. You just add / citation.cff to the ASCL ID and you get advance. You get this. Notice that this is a little bit more readable, a little bit easier to write, and the citation is very clear at the top with message, please cite the following works when using this software. Bam, it's right there. It's very clear. So this is a YAML file. It doesn't have some of the other information, or doesn't allow the input of some of the other information that the code meta file has in it, but it's easier. People generally find this easier to produce from scratch. And it's very clear what the intent is. This is for citation. And again, Cite As looks for this. Let's go ahead and advance. So why do we have these? So this is not an exhaustive list, but they're good things to have because they let people know explicitly how to cite your software. I can't tell you how many times I look at a code site and I can't tell what is supposed to be used to cite that software. So I can't include that information on the ASCL because I can't find it. It also allows this information to be ingested in other systems, such as Cite As. And I just got an email from the manager of that project, in fact, while we were talking, because we have an API now where they can ingest our information more easily. And then with uptake, these file types are being used in other disciplines as well. So as uptake increases, we can create one ring, one search engine to rule them all. That it's possible, it would then be possible to pull in a lot of this information virtually off of GitHub repos or wherever these files exist, and then create some way to search across disciplines for software that may be useful to you. Next slide, please.
Before you go on, uptake is something I had never heard of. What is that? Is that
uptake, just getting people to use it.
Oh, it's all right. It's English, and then the word ring. What does the word ring with capital mean?
It's does somebody know the reference that I'm making? One ring to rule them all. Lord of the Rings.
Oh, it's also English. I thought there were certain things that I never heard of.
No, it's not your doorbell.
So it's my cultural, yes, missing cultural experience. All right, next one. Sorry. Yeah, you get it?
So how do you get people to agree on one or two or three so that you can search across them? All of these two formats, codemeta.json and citation.cff and zenodo.json, which I believe is still going to morph into codemeta.json. They're actually going to give up their own zenodo.json and simply adopt the codemeta one because that's becoming an increasing standard. All of these and other competing formats for how to represent metadata in metadata for software have been crosswalked, and those crosswalk tables are on the CodeMeta site. So if you want to know what something is, what a field is in Zenodo and what it's called in CodeMeta, or what a field is in ASCL and want to know what it's called in CodeMeta, that's one place that you can look. Of course, it's always hard to get people to do something different. Well, maybe not always, but it is often hard to get them to do something different. So getting people to use a standard format, whatever that standard format is. What we've been doing is experimenting with actually sending these files out to code authors when we say, hey, we've registered your code. We're doing an A/B test where I send CFF and codemeta.files to the authors I write to. The other two editors do not send these files out, and at some point we'll do a comparison to see whether we've actually been able to trigger uptake of these by sending the files out. I hope the answer is yes, but we don't know for certain. I do know that some people have done it, but we want to compare sending them out and versus not sending them out. And of course, getting these files into other systems, they first have to be out there, and other systems have to, if they're not already looking for these, they have to start looking. We want them to start looking for these. So that's all I have. If you have questions about this, I'm happy to answer them. We have a new API as well. So if you want to pull additional information from the ASCL, such as preferred citation information, so that you can build another system to ingest that kind of information, we can do that. And I want to point out that the preferred citation we list comes straight from what you, the code authors, say on your own sites or within your software. We don't decide how your software should be cited. We take our cue from you. I'll also point out that there are, to get back to Bruce's last slide, there are software citation principles that have been written. A link to those is on an ASCL page, and I'll supply those links in the chat once I'm done talking, which is now. So thanks very much. Does anybody have any questions about that before we move on?
I don't see any open questions.
Nope.
Good, then we can go to item number 4, which, okay, this will be a surprise for me. I have no idea what's coming now. There was a licensing BOF this morning, and we decided, since we're also in some sense talking about licensing and discovery, if Jan, one of the people at the BOF, was going to say a few words, or maybe a super summary, what happened this morning for those who missed it. And, oh, there's a lot. Is Jan around to annotate this?
I think he's online.
Maybe the room manager can get him. Ah, he says he's coming. He said that at 2:10. Uh-oh.
Okay, well, one of the questions is Adrian Price-Whelan just wrote in and said, not a question, but I just started making a codemeta.json file for one of my projects. Yay!
Who do you want as a panelist?
Jan.
Yes, he just
with
showed up. Oh, somebody.
There he is.
There he is.
Yay.
Jan, do you see the slide?
I see the slide. Can you hear me?
Yes, excellent.
Yeehaw.
You want to give a nice quick summary of what you thought was interesting this morning?
Yes, so actually we try to make a summary which we may actually also use on Thursday. So any feedback we have from this is great. So I think the summary, well, we first of all, we were completely surprised by the high attendance, like 120 people interested in licensing. We were all completely surprised. So we did notice, well, it's widely accepted that source licenses are a must nowadays. I think our main conclusion is that a lot of people, it's a no-brainer that you should pick a license, but what license to pick can sometimes be a complex discussion because, well, you're very seldomly actually working in projects that you do on your own. There's always external constraints, and these things can be complex. We noticed from our questionnaire that permissive licenses tend to be a bit more used than non-permissive ones. Even if you look at I did a bit of deeper diving into the data. If you look at people who actually do not follow their own institute's policies, those are a majority people who actually have a more permissive license than their institute. The questionnaire is anonymous, so I will not point out people here. I think that also the discussion we had on relicensing, that is a very tricky business, that it's a very good idea to think in advance that software may actually live for like years and years in the future, and also to think about how to handle external collaborators. And I think that it's also clear there was some wish from the community to actually share best practices and learn from each other. And then I wanted to show the two main graphs from our questionnaire on the next slide.
Yeah, here it is.
So I think those are so I think the top graph shows basically what a typical license is that institutes have and collaborations have as a by policy. And on the bottom one, you actually see that how many people are actually using the type of license. So you already see that even though there are several, so there are a lot of people who don't really know whether the institute or collaboration actually has a policy at all. I think that's an interesting result there. Also, maybe actually referring back to the second BOF of today, which was talking about herding cats. And again, you see that the permissive licenses are I think, quite popular in our field. I think those are the two main things you could immediately say based on the images. Also, there was a lot of discussion that we could, I'm adding it already as next year's ADASS. I mean, we could easily fill a next BOF with all the questions we still are open. I think an important one was data licensing, and I think this may also apply a bit to this discussion. that data citation, data licensing, that whole package is also something that people are very interested in, and well, of course, is also getting a lot of attention nowadays. Well, contributions and contributors. How do you handle those? How do you deal with them? Also, the establishment and also importantly, the enforcing of guidelines and especially on licensing. How do you enforce your license at all? I think is also a question that I saw a lot of times also in the questionnaire, and was also well in our ranking. And well, of course, actually that already links back to the last point I made on the previous slide on the collaboration and the community-based approach on how, as a community, we can learn from each other and get our well things sort of well that we can learn from each other. And I think during the prep call I had with Alice there, we very shortly discussed how, for example, licenses are actually in the whole code meta kind of world, or how you would put them in, and the two formats that you just discussed. And I think that I think it's very typical that there doesn't really seem to be a standard way to describe your licenses in your file. So there is a field in the code meta that describes your license, but as we didn't really very quickly find whether there's a easy way to do it, and so ASCL basically puts in a placeholder. And I think that in itself is an interesting point to make, that it's not completely aligned yet, the world of licensing and metadata, I guess. But that was not a conclusion of the BOF. That's my conclusion from the preparation to this BOF.
Oops. All right, thank you, Jan. Any questions on that?
And of course, that URL is the page with all the info that we...
Yeah. So before I go on to the next item, Alice already showed the code meta file, codemeta.json, and the citation CFF. That's sort of more into what Jan just talked about. But we should also say codemeta.json also includes the citation. So that's probably the preferred one. Adrian just already went through the exercise. He went to his code, apparently. I think that is on ASCL, and he created one. You can then put that in your GitHub and annotate it more with more information, like what I did. And there was actually a question, I think, on there: what happens with that file? Will ASCL take that over? The plan is yes, but I don't think that's active yet. But I wanted to add something to that, namely, if you have a codemeta.json file in the root directory of, for example, your GitHub directory, GitHub repo, then there will be search engines that will find that. And so I was at a workshop that we had at Maryland about that. Now, that's not fully clear to me how functional that is, but this is something that works across all fields, you know, geology, physics, biology, and astronomy, and so forth and so on. And so with that search engine, you can then search through all kinds of fields and look for software. So the obvious thing that came up to me is, as well, you know, let's take my example of Nemo. You know, who cares that it's a Dynamics toolbox for whatever. There's not much information in there of the kinds of things that it does. So I discussed with some people at that meeting how can we deepen the code meta, because if you look at that file, it's sort of one level deep most of the time. But if you take, for example, a package like IREF or APES or Nemo or Myriad and so forth and so on, once you go one level deep, you suddenly have 100 commands, and they do all kinds of interesting things. So if you could grep, quote unquote, through that, you might discover quite a lot of interesting things about a code, a package. What are the subroutines in CFITS.io that are related to opening a bin table? Or are there tools in Nemo that work on a bin table? And you would never find that with only the top level, but if you go one level deeper, you could find that. All right, so that was sort of an exercise I did at that particular meeting. So that's what this slide goes about. Some years ago, we had code.google.com. I actually discovered only today that it's still there, but it's hidden in a subdirectory, in a sub-branch. So there's code.google.com/archive. I didn't probe around how well they maintained that, but it's basically, it seems like a dump from 2016 when Google stopped doing that. But I remember at the time it was very interesting, and I could find all kinds of interesting, functions that do this or that, and but it's very laborious to find your code that way. So the JSON, the code meta.json does have an option, and that's really from this thing that I labeled there, number 4, called schema.org. And if you go in there in the software application, you can find many, many items how you can describe your software, of which code meta.json only takes a fairly small portion of it. And this is this crosswalk that we talked about, what matches the things in schema.org related to software to what goes in code meta.json. Alice can explain to me if that's a proper way of putting it, but there's a lot more items in schema.org than we currently have in code meta.json. And the one thing that is missing is things like keywords. And this thing that I have as an example here at the bottom of this slide is the task list, or whatever we call it. But it would basically be a list of the name of the function or the program and what it does. And then that upper level search engine that goes all the way across all our fields, all our science fields, is then able to find across the fields things that you're interested in. So I actually have an example. I built that. It turned out to be super simple in Nemo to organize that task list, and it's completely automated. So I could automatically update this extremely simply in my code meta.json file. So that was one way how you could expand your code meta. I mean, it's of course not accepted. There's a whole committee that goes over this, but that would be an interesting expansion that we haven't really worked on a lot. But so that was one. And that sort of segues into the Unified Astronomy Thesaurus that I worked a little bit with Katie on, who is a part of this group. So that's the UAT, and formerly known as the IEU Thesaurus, I guess. And there's a bunch of them, and they were unified in a thesaurus. And if you go to the top of your typical science paper, you see the keywords, right? And you see some example there at the bottom in yellow. I took just some random 3 papers that had to do a little bit with codes, and they're just words or quasi sentences that are separated by semicolons. And if you remember that from the old times, it was often word, colon, and then some other words that belongs to that. It was a slightly different structure. And the AAS and other journals have now standardized on that. And these are the words that you can find as the leaf notes in the AUT. That is, it's been adopted by the AAS. You can find it on GitHub if you go to that link that I gave in item number 2. And those leaf notes that you see there in yellow, you can find in that particular in those particular papers. And like they have 3 versions of the thesaurus. There is one as a CSV file, and there's 2 other files that are less easy to read. So what I talked about before, these keywords, can we use that also in code meta.json, right? So then it turns out, I found out that a number of, if you go, for example, especially to astronomy and computing, they use a different set of keywords that are catching the software better, the kind of the algorithms, for example, that are not caught in the UAT. So that gave me an argument to say, well, we need to expand the UAT, of which, of course, they're happy to do, to catch more of the things that we are interested in covering, software and algorithms. And on the next slide, I have some examples. So in yellow is, again, the examples that we just saw from a bunch of paper that I took from AppJ or that an AAS blessed journal. And at the bottom, there's just some random examples from ANC. And you can see that that is the sort of sometimes the old style galaxies : photometry, methods : data analysis. And those are, of course, maybe the old style, or I don't know where they get it from. But if you just grep through the AUT, most of them are not in the AUT. There's no match on FITS, for example, or World Coordinate System. Let me go back to this slide. Let me see what I want to say else about this. Then I wanted to go to an example to get a better census. Oh, that's misspelled. The other census I meant. If you take, for example, the field of stellar dynamics, and let me just go to that slide. A good example would be to look at a niche at a small field, stellar dynamics and stellar populations. They happen to have a meeting coming up next month and a follow-up meeting a year from now. So that would be a great opportunity to get some domain experts in one room or one virtual room, and with them decide on what is a good census of the software that is used in that field and what are the keywords that we need to describe that particular software to add in our additional AUT. So that's an idea I have. I was planning to go to that meeting and bring this up in a session and see if we can get these people to think and work on that in the next year and present this next year at ADASS, presumably, but also at their meeting, which they have in November 2021. I think this is in Australia. So that is, yes, that is it in terms of the deepening what we can do with CodeMeta.json and how we can help discovering our software in a better way. Okay, so Alice, I hope I didn't lie too much when I talked about these crosswalks.
You think I was listening to you?
Oh, that's okay.
I've been
so
like posting links. So
if you, I presume I talked about this workshop that we had. I think we have a blog about that, isn't that so?
I'm about to post the link. I just pulled up the link.
Thank you so much. I was just thinking about that. So if you want to know more about that, what the other fields are doing in terms of that, because yeah, it's nice if you make your CodeMeta.json file, but you know, where does it go? Where does the information go? Who grabs it? So there's a lot more in there. But as I said, I don't know quite the status of what happened after that meeting with all of these ideas.
Right now we're working on best practices and a quick ref guide for repositories, and registries that were there. I mean, this was a broad cross-disciplinary meeting, so we got people from all over, lots of different disciplines in. We had somebody from CET, somebody from Zenodo, which you can see if you look at the participants list. We pulled these people together because we don't talk to one another. I mean, overall, people who do what I do in another field, or people who, you know, work on, I mean, I do talk to Zenodo people, but I wanted to talk to other people who kind of do what I do, and we had this workshop that was great, and we're working on something to release by the end of the year on policies, best practices, or quick start guide to services like us. And
so this group is still regularly meeting, Alice?
No, it hasn't. Well, it hasn't been meeting. Hasn't been meeting very much during the pandemic. So,
yeah, I know before you did, but
yes, but we had been holding monthly meetings. We actually were holding, and when we start up again, we'll hold 2 meetings a month. They're both on the same day, and the reason we have 2 is because we're around the globe. So we get some people at the early meeting in the day. We have it at 11 a.m. Eastern, and then we have another one at 6 p.m. Eastern on the same day, and that allows us to go through our to-do list more quickly, because we do, you know, the people in the first meeting do some, and then the people in the second meeting follow up on that and do more. So there's a lot going on with metadata. There's an RDA meeting going on now, so where metadata is much discussed, both on data and software. Mm-hmm. There's just a lot going on in these different areas.
I thought that was a fascinating example of cross-fertilization going on at that meeting. There was a guy from Amsterdam, and he had taken this project that came from astronomy. It's called AMUSE, And AMUSE, which you can find on ASCL, it's a project that is basically a Python hub that collects all the data structures and code in legacy codes. So it takes an n-body code from like RSET and maybe an Eggleton stellar evolution code and hydrodynamics code from this. And in the Python hub, you can then tweak which components you want. And you can then, for example, evolve a star cluster with stellar evolution, with gas in it, and all the dynamics on the different time scales, and do that all correct. And that idea of this Python hub with these legacy codes like spokes around it that you can still reuse in Python, because Python doesn't do the computation. That's all done by the legacy code. Python is just the orchestrator to take the time steps. So there was a group that took that from Amsterdam, and I believe it was hydrology. I don't know if you remember that, but they took that whole project and took that whole idea and took their legacy codes and took the infrastructure from AMUSE and wrote a very successful package that was basically cloned. I was extremely impressed with that.
Yeah, so there was a lot going on in that meeting, and there still is. So we're still in touch. Somebody from Software Heritage was also there, and I mean it was
yeah. So you can find information on that on the blog. So I think we're basically done with the things we wanted to share with you. If I look at the clock, we have spoken for, is that 45 minutes? Wow, that's a pretty good estimate. One idea we already have, which I put myself already on number 8, is to, of course, we're going to have a little write-up about this BOF, which is limited to 4 pages. The licensing BOF will do something similar. And we thought that it might be useful if we write some of these best practices and code meta, all of these things we talked about today, to have that in a little white paper that people can use and just learn about how they should make their software better discoverable and properly cite. I know we've spoken about that at the AES and at various other times, even at ADASS. But it doesn't hurt to have that in a bigger write-up. So maybe we will turn this into a white paper. Who knows? So that was number 1, and I think we should open the floor and see if there's any other items that people want to either present or ask questions about to any of us or the others. Nuria gives me 1 thumb up to the white paper idea.
We want to make sure though that we're not duplicating what's already out there. There are the software citation guidelines that are out there. There's a lot of information on licensing, so
yeah, but people, well, obviously there'll be just references, but I suspect there's lots of people that don't know about these references, where they are.
I mean, one part of the white paper, if we do it, would be maybe to have, excuse me, 2 or 3 worked examples from different types of software that show how these metadata examples are created and what they look like.
Yeah.
But that would involve, several people being willing to do it. I'd certainly be willing to help out on that one if we went that route. Mm-hmm.
Yeah. And I also discussed the fact that this example of the task names is not in codemeta.json, right? And I have a feeling that this might be a very useful thing. The question, of course, is that how difficult is it to maintain that? It could be complex.
Yeah, I was going to ask that very question.
Yeah. Now, if you have, in my case, I wrote a little shell script that you can find that in my GitHub repo. It turns out to be extremely simple to do that in Nemo, but it depends completely how your package was written, right? If you have something like cfits.io, and if you wanted to do that, well, maybe you need a parser for the, you need one-liners for every subroutine and function in cfits.io. And it's optional, if you don't do it, then you don't get it. And it would have to be ratified and understood by the people that write parsers to help you search these codemeta.json files. So it's not there yet, but I would like the idea that exists as an option. read some of these. Alice is already answering some of those.
So an interesting question came up that I now can't find because things are scrolling so quickly. Oh, so as a simple example, what do we do about closed source packages? Well, of course, ideally, we would want them to be open source, but even if they're not, the metadata for them can still be made available. You can still find out what the name is, how it's licensed, what kind of work it does, and all of that. So there's still a lot of closed source.
So where are these code meta.json files stored?
They could be stored, you know, wherever information about the code exists.
Right. So on IDL's website or so.
Yeah.
Yeah, and I remember that we talked at the workshop about having these registries. It reminded me a lot on how the IVOA operates, because you know you have geology that has a server that knows where all of their code meta files are, and servers, and they need to talk to each other. And so that sounds a little bit like an IVOA concept.
Maybe it's something to discuss at the IVOA meeting next week.
Yeah, I think we sort of brought this up once, and with Bob Hanisch, and he didn't seem too hot on this, but maybe it's time to reconsider this. Yes. I'll see if
and
I
there
can
is a
remember
working
that.
group dealing
Are you
with
going to be
these.
there, Bruce?
I will be attending, yeah. There is a working group that is responsible for these issues. So I would tend to think it's a very good time to bring it up again.
Yeah, yeah. I remember Bob was a little. He was worried, I think, about the maintenance of metadata, or not clear how well you can describe that.
I'm sorry, if memory serves, I think he was concerned with the metadata becoming rapidly out of date as the versions advance, and how would that be handled? And I don't think at the time, which was a number of years ago, of course, I don't think at the time there really was a good answer to that. I don't think anyone had given a tremendous amount of thought to it.
Well, if you store it on the GitHub repo in the root directory, you know, the author ought to make them consistent. It's like keeping your documentation consistent with your subroutines and so forth.
Yes.
And I happen to have a mechanism in Nemo where the code contains the one-liner. So when I update the code, automatically those one-liners get updated. And so in my case, the syncing is trivial. It's just part of the building process.
Yeah. So something to put in the white paper.
Yeah, I listed the name of the function, so I'll remind myself that should go in the white paper. But yeah, that's a good idea. Let's discuss that next week. And then there's also the issue, I remember, that I ran into what astronomy and computing does for keywords, because they don't seem to be using the UAT. And I don't know if there's any of the board members here present, but I would guess that the keywords that we have in the UAT are just not sufficient for astronomy and computing, and they stick to something older. So if that's not the case, we should really talk to the UAT people and you know, go through the process of a census of software and finding a better description of our software on that level.
Peter, the discussion is wild on Discord. Do you want to open the floor to some of the attendees if they want to talk?
Yeah, I think people should just raise their hand and then also talk. We're recording. I agree. I'm having a hard time following everything, although I see that Alice is really heavily answering things. So people
I'm
should just
trying.
raise their hand, and I'll give them speaking permission.
Yeah. So one thing that's interesting is that Peter Williams just asked. So then the plan will be to have a central location for that metadata. And I was just typing my response to that as well. That could be one result if people put a metadata file on their code sites, whatever code site that is, or make it available, then there could actually be something that would go out and build a registry or a central location for that metadata. It could be done automatically, and if information is added as to the domain, for example, which discipline this comes from, you could. It opens up a whole world, a whole new world of discovery, because there are codes that are useful in medical imaging that are useful for astronomy, and vice versa. There are astronomy codes that are being used to analyze MRIs of knees, for example. There are these cross-disciplinary uses of the research software that is available out there in the world. But how many people in astronomy are going to go look through medical imaging code to find something useful? Whereas, you're not going to do that explicitly, but if you have some way to capture metadata about all these different software packages, then you have an opportunity to build something that can search across all of them too.
Yeah, I'm getting another plug for doing. Oh, we see some hands? I was just looking at the sample that I have. I see code repository, of course, but there is no guarantee. Let's say that this file is going to live by itself. Somebody stole it, puts it in a database. Now, how does that database know that it has to sync it to make sure that I didn't make an update, right?
Can I mention a few things here?
Yeah, go ahead.
So this is Peter Williams. Yeah, I guess just sort of what was prompting some of the questions that I've been asking with some of this stuff is I think exactly this question of, from what I've seen of how the web works, metadata don't automatically self-organize. You need these kinds of central hubs to really spur people to actually fill in their metadata correctly. And when you get duplication and when you get, when you don't have that kind of, people write their metadata files such that they show up correctly on, such that Google indexes their websites correctly or whatever it might be. And so I guess as I've thought about this more, I tend to convince myself that really that end of the equation of like, what's the hub that everyone goes to? And for me, I feel like the question is, okay, you're a working stiff scientist, you want to cite CASA, how do you get from that to BibTech? That seems like the hub that things should be going through. And I feel like, once we have that hub, then the metadata will kind of figuring out how to organize that will become a lot simpler in a certain sense, because that will sort of orient our thinking about how everything should be gathered and organized.
No, it's this is Thomas Jürgens. It's like a robot, right? Like a Google robot that harvests information from sites. That's what you need, right? So if everybody puts their citable metadata in their repositories, you just search through the repositories and grab the contents of these files. Then you store that in a database. You eliminate duplicates, and Bob's your uncle. Suddenly you have a database that is full of the information that you want, right? Cross-referencing the citable information with the location where the code can be found, right? Then you put that on some central web page, make it searchable, and then you have created your central location for exactly that.
Right, and as these types of files are increasingly used, of course, something like Google is going to search them because it's useful for them. That helps people find what they're looking for if there are some standards to how this information is formatted.
And also, the IVOA has had a registry of services for many years. Why not also have a registry of software?
Yeah, the problem that
Yeah.
I see with registries is that first, people have to know about them, and secondly, people are lazy, right? So
Oh,
do
yeah.
I spend half an hour? Do I spend
No,
half an hour of time to register my code someplace, or do I just do anything else to improve my code or bug fix or service a user request or such things, right? So if this can be automated, we take that responsibility, that burden out of the hands of our software developers and make it easy.
But I guess the point that I want to make is that creating that database is not an automatable process. I mean, you know, some of us work close to the folks at ADS, or, you know, knowing people who work at Google, like, you know, the Google search box looks like it's just magically slurping things and organizing them the way you want. But there is a lot of effort that goes into doing that synthesis and removing all the duplicates and keeping everything up to date. And, you know, there's just, that database is actually super hard to create. And honestly, that might be harder than, you know, once that database exists, people will populate it if they see the path to do it. But without that database, there isn't really going to be the North Star that guides people as to how to organize their metadata and where to put them.
Yeah.
Yeah.
Well, that initial database could be the first step, right? The stepping stone that is necessary, the kickoff, right? Incentives gives the incentive to everybody to really contribute to that database, right? I mean, look around in the commercial world, right? Once Google actually started harvesting information from web pages for advertisement reasons, people started paying Google to get into that database, right? So what I'm trying to say is, well, you need to have something first so that people see the reason why they want to contribute to it.
Yeah, and I think the idea that I have is I feel like a sort of Wikipedia kind of model of, you know, I think having a really low barrier to entry where people can add an item or propose updates to an item, like with super, honestly, low supervision, is probably the kind of way to think about how to bootstrap that kind of effort.
I think all of the ASCL data has been Wikidataed, if I can make that a verb. I haven't done it. I've not been involved in that, but all of our data is available publicly, and I will put the link. Well, I'll tell you, it's ascl.net/code/JSON. That will give you all of our public data. So that can be used for good. Don't do evil things with it. But that's, you know, and there is a lot of software metadata around of course in astronomy, because there are numerous different ways to get it. Of course, ADS has a doc type software, so you can search ADS specifically for software entries by doing doc type :software, and that will get you, it's mostly Zenodo and ASCL records, but increasing. You know, we're happy to create them where we can so that you can use them, but our next trick is our next goal is to, when you make a request for a metadata file for either codemeta.json or citation.cff from the ASCL, we want to check to see not update their metadata ever. And we may have more up-to-date metadata than what is currently on somebody's site.
Alice, I just lost you for 10, 20 seconds. Is that just me or did everybody?
Yes, my audio is cutting out. Sometimes my internet connection is unstable because I'm running, 3 phones and 2 laptops, and I don't have very robust services. So sorry about that.
So then the first idea would be to harvest the initial data set from ACL.
You can do that, and we have a new API. We have a poster that we're presenting. Our Sita Mavram is presenting a poster at ADASS on our new API. We've just made this available publicly, so you can actually go out and search for everything that does not have a preferred citation. And if your code is on that list, please let us know what your preferred citation is. But then
poster P9103. I mentioned it in one of the first slides.
Yep.
And that's simple JSON files, so you could even grab them yourself and then write your little parser to it, because you can just absorb them and query them. But the idea is, I don't know how far they are with that, of actually providing web services for this online somewhere that we can search through certain disciplines where we register, like, for example, here's all the ones from astronomy and so forth and so on.
Well, we're working with other disciplines to try to do the same thing. One of the things that happened at the workshop a year ago was encouraging these other repositories and registries to do the same thing that the ASCL is doing, which is creating these metadata files for their code authors. And I know that several other disciplines have decided, yes, they're going to do that. And they'll encourage their authors to put these files on their code repos as well. Because I really see that's where this idea gets really powerful. Standard metadata improves, makes it possible to do so many really interesting things, most of which I can't even think of because I'm just not, that clever. But you all are, so I know you will think of really cool things to do with it.
Yep. Okay. Peter still has his hand up, but other than that, I don't see it. Yeah, thank you. You still have privilege to talk, by the way, both Thomas and Peter.
I was wondering how hard it can be actually to write a small spider script that goes through all GitHub repositories. I mean, GitHub should have an API, right, that allows me to search for certain file names.
Yes, it has exactly that. You can do that kind of thing.
You can do that quite easily, but the thing is, there's probably going to be 0.01% astronomy in there. But if you just want to have
it's a start,
a wider
right?
field, yeah.
Just to see if that's a kind of a working idea, right? I mean, just to get going. I mean, then it needs some iterations, of course, and the solution has to be turned into something really useful. But just the initial step to get going, to get some traction.
Would that work, you think?
I don't know. I'm optimistic.
I think there's you give it like file name : that, or there's some way to search for files with a particular name.
Like they do in ADASS. Well, it can be done.
Yeah, you see at the bottom of your screen with this file name. In the code options.
Yeah. Yeah, these are examples. Okay. I still don't know how to have to prefix that.
I think you can just fill it in and then. Or
Yeah,
no.
just type in the file name.
You should type it in. It will.
That's what I did before, but that don't.
I think now you can use the advanced options and extend your search with them. So I guess you have to search for star or whatever, and then click on. So if you empty this box and you fill it in the file name box downstairs.
See, I only get 5. On wikis.
Jan just posted the search and it returned 1,181 code results that contain the file name codemeter.json.
Yeah.
So that's
okay.
promising.
That's better.
Jan, you are my hero.
Oh, file name. Okay, file name colon.
Took me 3 boss for someone to say that. Thank you.
All right. Well, Alice, we have more codes in the ASCL than that.
Yes. So as I said, we've been experimenting with how to improve uptake, and one way of these, of codemeta.json and or citation.cff, and one way to do that is to present at conferences like ADASS and get everybody listening to put these files on their GitHub repos or wherever their code exists, because you've been to this BOF. So,
and can you see who's the first one in that list?
Well, Adrian Price Whelan wrote in while we were talking about it that
Oh, no. I meant on the GitHub search. Look who's number 1 on that list. Is it too small?
Well, I'm not looking at it right now, but.
Oh, well, I'll give it away. It's Mike Hucka.
Oh, Mike Hucka. So yes, so Mike Hucka works in biological modeling.
Yeah. He's at Caltech.
Sorry, he's at Caltech, and he is one of the people working on these policies for code repositories, because he runs one for systems biological language system SBLM, I think SMLB. So he runs that, and he's currently creating a way to create code meta files from the metadata that is in that particular resource, which he set up. So this is, again, somebody from another field who we've talked to and we're working with. Actually, Caltech was received the funding for the workshop that Peter and I have both mentioned. That was a year ago. So we partnered with Caltech, with these people in systems biology, to put on the workshop. They received the funding and it got put on at University of Maryland.
Oh, this one is a little bit more filled out. Oh, this one even mentions the funding they got.
So yeah, that's another thing that's a schema.org field or or set of fields for funders.
All right, quite interesting. So now you've learned all about CodeMeta.json.
Maybe not all about it, but certainly enough to build your own CodeMeta.json files. There are also systems out there. CodeMeta, if you go to CodeMeta.json, they have something that will help you create a CodeMeta file. So does citation.cff. And there are other generators out there as well. But you could just use the ASCL and then augment and edit that file too. That makes it easy. And as I said, we worked with the creators of both of those formats to make sure that we were doing it correctly. They were both at the meeting last year too.
Yeah. Mm-hmm. Well, I'm ready for a beer.
I'm ready for 2.
I have 4 in the fridge here, so you're welcome.
So we're meeting at Peter's.
No. This was 1 beer for every end of the day. That's why I have 4. Ah, the parcel tongue has now also. Mark is the second one. Well, shall we wrap it up? We still have 15 minutes on the clock, but
Well,
yes, everybody's happy to
Can I
stop
throw out
by
a
here.
question to everybody else?
Yeah, of course.
Is there something that we could do, you know, either through the ASCL or through this larger workshop group, you know, of code repositories and registries that attended the workshop or are involved in the workshop activities from last year? Is there something else that we could do to make things easier, to make it easier for you to create these files or use these files, to convince people in your institutions to create them? Or is there some other way? Is there some way that we could help? Or do you have ideas for other ways to improve adoption of these metadata files? Oh, please have ideas.
There did seem to be quite a bit of interest in doing a white paper. Although, you know, it's one more task for people to do and everyone is already very busy. I would certainly be willing to contribute to such a document if we think that that is a very good thing to do. Or maybe it doesn't need to be a white paper. It can be a web page somewhere containing the same content.
Mm-hmm. But when we say white paper, presumably you want to put that in archive.
That would be the idea. Although practices tend to change, and so a white paper would presumably go out of date fairly quickly, I would suspect, and therefore maybe a web page that could be kept up to date might be a better solution. Although again, that requires work for the maintenance and the updates.
So Alice, do we
Bruce,
we have the blogs on ASCL. Do we have static pages that we could edit and update as the practices change? Kind of like a wiki?
Well, perhaps a versioned white paper.
Mm-hmm. That would work too.
Yeah. Well, the proceedings paper is already on Zenodo, and once that has been submitted to Francesco and company, we can just uplift it and make it the white paper. all the infrastructure is there. So let's do the proceedings paper. That's only a week of work, right? And then we'll just go from there.
Well, it's a day of work and 6 days of cussing at LaTeX.
That's certainly my
No.
experience.
Not an overleaf.
That's true. Overleaf makes things much better.
It's already in there. I have the link for you, Bruce. So that's the nice thing about the personalized templates that we have for ADASS. It's not automated, but it's just 1 or 2 extra steps, and what you get from the lock, you can stuff it pretty easily into Overleaf and then just work from there.
Yes, I've done that with my 2 papers for this conference, and yes, it's a good idea.
It's too bad that we cannot submit from Overleaf to ADASS, right? You have to grab it again, make it a zip file, and then give it a certain name, and then so that step is still a little manual.
But you're on the park, right? You could maybe change that.
Maybe I'll see if we can do that in Cape Town.
So Peter, are you done?
I think so. You were very quiet there.
Yes. Well, I'm just here to assist the boss or the lead.
I think we're done. There's a lot of things to mull over in the chat. That's good. Okay. I couldn't really keep up with that.
So people, you can continue the discussion on Discord.
Yeah, in this room, we will monitor what's going on and then go from there.
Excellent. So this is the end of this session. And the next session is tomorrow for many of you, this evening for me. So we have 9.5 hours to break, to work, to sleep, to whatever. And we'll see you then.
Thanks very much, Kathleen. Thank you, everybody.
Yep. Thank you all. Bye-bye.
Thank you.